how to animate puppets. And the first thing that I'm going to discuss is equipment. And equipment is important for capturing animation frames or frames of animation of a puppet which you've repositioned. And it's sort of a really touchy subject because you can spend, literally thousands of dollars on this type of equipment. So some of the things that I want to discuss are the types of cameras which are important for capturing the frames of animation and what you need to look for. Now I actually recommend 16mm cameras like these. This is a Russian Krasnogorsk 3, and this is a Kodak Cine Special, and the Russian camera is more modern. Since the Cold War is over, the U.S. has sort of seen a lot more photographic equipment shipped over here, and the Kodak Cine Special is probably made in the 40s sometime, 1940s. So these cameras are actually really old, but if you find one that works good, these cameras will last almost forever. And there's some problems with the older cameras which are spring wound. So now some of these older cameras, the lubrication is so old, 60 years old, that the springs actually stick as they're unwinding. So a lot of these old cameras, what you'll get is a flickering problem when you play it back. So the more modern Krasnogorsk 3 cameras from Russia, even though they're probably not as solidly built as the older ones, usually work better with the spring mechanism. And the other type of camera which is really popular in 16mm is the Bolex. And these spring-wound cameras are really good for beginners, I guess I would say, because you can learn on them, you can learn how to set the exposures, and maybe a little bit about lenses and whatnot. So even if you get a cheap 16mm camera, they'll still do a good job, just it won't be as professional and also as expensive. So if you're doing it, let's say, as a hobby, you'll probably want to go with the Kodak Cine Special like this, or the Krasnogorsk 3. But there's also other cameras which some people have used with a lot of success as far as a beginner standpoint. And I learned on a Canon Super 8 camera, and the film in Super 8 is actually very narrow. As you can see here, this is a strip which is maybe 1/4 of an inch or so in width. 16mm film is a little bit thicker. Obviously the image size that you're capturing is about 16mm. And then there's 35mm, and a good 35mm camera is either a wall camera, W-A-L-L I believe, and a Mitchell camera, Mitchell 35mm. And those two cameras have to be outfitted with stop motion motors because I don't believe there's any actual spring winding in there, if I'm right. But 35mm is actually really wide compared to any of the other diameter films which you can use to capture animation. And since there's more of an area for capturing an image when it's projected, you actually have a sharper, clearer image as opposed to the other formats. And there's also variations in film, such as if you buy 16mm film, which is 100 ASA, the film grain is actually tighter and will give you a much more sharper image. But you also have to expose your set and your puppets to more light. So there's a real lot of technicality to understanding these old film cameras. But Super 8 is probably the cheapest um, format for animation. 16mm is the second cheapest, obviously. Um, and it's more widely available as well. It will give you a better image than Super 8, and also more options with lenses and things. Um, because some of these, like you can actually get a screw-in Pentax lenses into the Krasnogorsk, and with a Bolex, if you get a Bolex 16mm camera, you can actually get lens mounts for all types of 35mm cameras, like a Canon or whatever. And the same goes for 35mm Wall and Mitchell cameras. But in all those cases, you had to actually pay somebody to install a lens mount for those cameras. This here is a 200 ASA 16mm film, which is a tungsten film, and it's also double perf, and it's 100 feet. So that's sort of the standard size for most Bolex cameras. And let's see, and you can see what it looks like when you actually get a new spool. Looks like this, and it's got a dark side and a light side. Now the light side is actually what the light is exposed to in the camera. And this here has a special emulsion on it so that when light hits it, it'll capture the image. So this type of film is also a daylight spool. And what that is if you look at the film in this angle here, now they have it wound on this spool in such a way that the film overlaps itself on the edges, stopping light from passing inside there, and also allowing you to load your camera without a darkroom. So the type of film you want is 16mm double perf, tungsten, a daylight spool, and the ASA you can buy whatever you want, but as a general rule, 100 ASA has the sharpest image, and if you buy, let's say, 800 ASA, the image is a lot grainier. But with 800 ASA or 400 ASA, you can animate your characters with less light. To use these cameras to capture your animation, a lot of people think that the frames per second setting on a camera like this has something to do with animation, and actually it has nothing to do with animation at all. 8 frames per second, you have 24, which is between the 16 and 32, and you also have up to 64 frames a second. Now, what does this do? I mean, why is this here if it has nothing to do with animation? And a lot of people get confused and they think, well, 64 frames, that must mean that it'll take 64 moves of my puppet for each second. Well, in fact, what this does is, I'll see if this works here. I'm going to put this at 8 frames a second. Let's see. I'm going to press on the button to see what the camera does. Here's the insides. I'm going to press on the continuous motion here. Let's see what happens. 32, and here's 64. And what's happening in this film gate behind there is it's opening and closing and letting light pass through the lens and onto the film. What that means is that more light is exposed on the film coming through here, through the film gate. More light is being exposed on the film at the slower frame rates. So that's one setting which allows you to change that. And there's also the f-stop. And the f-stop is actually, it sounds technical, but it's really not. Let's see here. Take one of the lenses off. Now this particular lens has an f-stop setting. Now if you can see through there, you'll see this iris. And you see how that closes and opens? That's what the f-stop is. So the light comes through the lens, and behind the lens is the film at that film gate. So depending on how much light we want to pass through, we can change the f-stop to less light going through to a lot. Here's a real world kind of example of how to set up your f-stop and film speed for your 16mm camera. And the same thing actually applies to a Super 8. Okay, what I've got here is a gray card, which is just a piece of cardboard, and it has a neutral gray paper over the front of it for the purpose of bouncing light off of what you want. Let's say we have our puppet here. We want to know how much light is bouncing off this puppet. We place the gray card in front of the puppet and aim it at the lights which are shining on the puppet. So like, let's say you have a key light which is above, you know, from here shining on the puppet. You want to sort of aim this at that light and use this, the bounced light off of this, to bounce onto a light meter, which is something you can buy both of these actually at like a camera shop. And the purpose of the gray really is to diffuse the light and get a very even tone, as opposed to something that has a lot of ridges and bumps, and you really can't get an even reading off of a puppet. So you use a gray card to get the reading. And light meters are used to set your f-stop, which is the iris in your lens, to bigger or smaller, depending on the amount of light that you have shining on your puppet. And why is that important? Well, the film itself can be overexposed, meaning that, you know, you can get a very washed out bright image or a very dark image which captures less information on the film and will look almost black if you don't expose enough light on your subject. So something like this character here can look like he's on the sun, for example, you know, if there's too much light shining off of him and onto your film through the camera. So the f-stop will shrink down the amount of light coming through, you know, to darken everything or make it brighter, kind of like this. That's sort of how it works. So we want to get the correct f-stop, or the correct amount of light coming through that through the iris of the lens and onto the film, according to actually three things. We have the film ASA, which we're going to use 200 ASA tungsten film in our camera. That just as an example. And we're going to set the film speed to, let's say, 16 frames a second. So we're going to have 16 frames a second, 200 ASA film. Now what do we put the f-stop at? Well, the f-stop, let's see, according to this lens here, will go from f2.7 to f16. So everything in between f2.7 and f16 is what this particular lens is capable of doing. And different lenses have a different range of an f-stop. So certain lenses can only open the iris a little bit, and some can open it a real lot. And really what determines that, I believe, is the diameter of the tube inside the lens itself. So if you get a really small itty bitty lens, it's actually easier to open those up, as you know, because the lenses are so small. You just open it a hair, and it's like, you know, it lets a lot more light through. But at the same time, those lenses are so small that they sort of act as an iris in themselves, letting less light through. So it's more of a technical reason why that is. But you always want to make sure that the lens you use is capable of letting enough light through onto the film so that you don't have any exposure problems. So how we're going to do that is we're going to take our gray card and angle it at our puppet, or at our light, the key light, which is aimed at our puppet. We're going to take our exposure meter and we're going to make sure that the ASA is set at 200, which this one is. It's already set at 200. But this has the option of being changed by just moving this dial. And we can have, you know, 6, 12, 25, 50, 100, 200 ASA, all the way up to 3200 ASA, which I don't even think they make that. So that's what we have here. Is we've set the ASA correctly, and then we're gonna take this exposure meter, and we have a photocell. And some light meters are different, but this photocell is what we're going to aim at the gray card. And you see there's a little dial kind of going up and down right here, as you can kind of see. And the reason it's going up and down is because as I aim this at different areas, there's more light falling on it depending on where it's angled. Now the card set up, and we're going to aim this right at the card like this. And we're going to take note of where that needle lines up. It lined up right with this third black line. Right there. So we set this other dial, which has this red mark, up with the third black line right there. And you have the option of course, moving it up or down, depending on where that needle is along here. So let's say if the needle was here, we would have it where it is now. But we had it at the third line, which is there. So now what do? We have our ASA set. We know how much light is bouncing off our character, and we lined up our meter with that black line. And now we want to know what our f-stop is. So we look at the bottom here. Let's see. Get in focus there. And we have, and it's kind of hard to see, but on the bottom we have red numbers along the bottom. And those are our film speeds. We have 16, 8, 24, 32, 48, and 64. Right along the very bottom. And if we follow those up, we can see in a straight line at 16 frames per second, that's our FPS, frames per second, we have to set the camera at f32. And then we're going to set the f-stop accordingly to our FPS. Now we set our FPS at 16, so we're going to look at our light meter and go, okay, we need an f32. So we don't have an f32 on here to set this at, because this particular lens only goes up to f16. So we look on here and we go, okay, what about 8 frames a second? Let's see. Well, it says here at At 64 frames a second, that would be f16. And this particular lens goes up to f16, so we have to set this, the FPS, at, let's see, 64 frames per second. So we swing that around. And so we've had to sort of make a compromise, because we had the option of changing the amount of light that lands on the film using the frames per second and the f-stop. So those two work together to help you set your camera up correctly. So we know that at this setting, this is good enough for shooting anything we want on the set that we just took the light reading off of. There's one final thing, and it's a technical thing, which is film related, and that is once we have the camera set up to the proper lighting on our subject, which is this guy here, there might be dark areas. Like, take for example this guy's pants. They're pretty dark. They're sort of a dark greenish color, and his face and his head is a light color. So there's a chance that there might be parts of this which are underexposed. Zoom in here. Areas like the shadow under his pants, or maybe under his arms in here, might be underexposed. So what we want to do is we want to set the f-stop, if possible, on our camera one full stop more than it already is, which isn't too hard on this one. We just move it over a little bit. So that's another important thing, which is just a sort of safety measure, I guess, for film cameras. It just allows you more flexibility as far as a safety net, just for the purpose of capturing more information on the film. Okay, the next thing you want to consider purchasing possibly are digital cameras. And there's a lot of different types. This is a very old camera. It's a Panasonic, and it takes VHS tapes. Let's see here. Inside the side here to capture live action, which is like what you're watching now. And these kinds of cameras are pretty old. Nowadays, what they have really are high 8 cameras, which use smaller little tape cartridges like this. And these are about $10 a piece, so it's kind of expensive. But they don't really capture animation well. You can't really take them and capture a single frame, you know, like this on 35mm. You have to usually hook these up to a computer in some way. And with computers nowadays, they come with what are known as capture cards, or you can buy them separately actually. And they're just a card about this big or so. And you take them and you plug them into empty PCI slots in your computer. And then what that'll do is that'll enable you to take a camera and hook it up using analog cables, something like this. You can kind of see a silhouette of there. They're just small round connectors which go from your camcorder and into your computer. So what that'll do is that'll give you a live image, well, if you get the correct software, of course, like Anasazi on my site. They'll give you a live image for you to capture. So if we have a puppet like this guy, and we set our camera up, you know, however, the camera is hooked up to the capture card in your computer, and a live image is fed of your character through the camera to your computer, and then since you can see a live image of your character, you can usually capture like a JPEG or bitmap image of your character directly into your computer. And once you have an image stored, a digital image stored, you're able to um, play captured images in a series, just like film, but in a computer using a program to compile all those images into a movie. So that's something which you can't really explain it because there's so many different ways to go about it. Possibly the cheapest way you can do it is to get a $20 quick cam camera, and those hook up to a computer using a USB port, which is just a rectangular, this is a round connection, but you can get a rectangular one called a USB port connection. So that's one possibility to do that. And the other way to capture images is to use memory sticks. Okay, this is a 4 megabyte memory stick, and it plugs into a Sony camera. See there. And you can get these up to 128 megabytes, and that will capture approximately 600 stored still images of your animation. So what happens next is you'll take that, which is already inside your camera, and you'll usually use either a USB connection or a FireWire cable connection directly from your digital camera, which has the memory stick in there, and hook that up to your computer's capture card. So the capture card is sort of the key thing, really. I mean, you need to have a capture card to pretty much do any of this type of work digitally. So there's different capture cards you can use, but one of the more the cheaper ones, which it's also pretty good, is the Pinnacle Studio DC-10 Plus, and that's currently what I'm using right now to give me a live image of animation using this sort of system. So really, I mean, what are the things you have to think about when you digitally do animation? Well, the first thing is that cameras aren't the same, really. They don't have, like on our film camera, they would have a FPS setting where you can take a dial and go from like 8 frames to 64 frames a second. These cameras don't have that because they have a steady frame rate of 30 frames per second. And these here, digital cameras, when they capture, they don't capture single frames. They actually capture a spinning head lands on tape and captures at 30 frames a second through a diagonal motion, actually. So they're completely different than film cameras, and nothing really applies. But one of the things that I suggest for anyone who seriously shoots using digital is to take the auto exposure and turn it off, and take the auto focus and turn it off as well. And the reason for this is because if I'm working on this puppet here, and I have the cameras, where you are right now seeing this, and I'm in here and I go to animate this character, and then I move away, well, the autofocus is always changing. It sees my hands going in there, and I move away, and then it has to constantly change the focus. And with auto exposure, the same thing applies. Like my hand here might be bright at this angle, and the exposure says, well, that's really bright, so we have to darken everything. So it darkens the screen and gets it out of focus. So when I'm in here and I'm animating, and I move away quickly and click off a frame of animation, what happens is each frame will be inconsistent with the one before it, leading to a flickering and a slight blurriness to it. So those are things that you have to consider as far as if you want to capture a good solid image. And when you're capturing on memory sticks, the same thing applies. Even if you're using the live image feed, digitally the same thing applies, where you want to turn off the auto exposure and everything. And that's pretty much it for digital cameras. You can get really expensive ones. You can get really cheap ones. I have a 1 megapixel Sony camera which will capture live and also capture the still images on these little memory sticks. And that's what I actually would recommend as far as a high-end camera, is to go with a camera that captures single stored images as well as live action, which is what you're seeing now. I'm just moving around and it's capturing on the tape, because you get the best of both worlds. If you want to film a family reunion, you got that option, plus animation, and it's just more bang for your buck. So digitally, that's really all I'm going to cover, because I have information on my website. If you're interested, you can just go on there or email me, and I can send you links and whatnot to more information. But those are just the general rules as far as digital. In this part of the tutorial, I'm going to discuss what motion control is and why it's important for clay and stop motion animators. This here is a motion control rig which I built for my 16mm Krasnogorsk, and it's something which is sort of a modern way to take a camera and have it fly through a scene of your animated film. And this is a really basic one. Now in Hollywood they have these types of configured tracks which control cameras through a three-dimensional path, and they use what are called stepper motors in Hollywood, which are these things. And you see here, that's a stepper motor, and it has this wire which comes off of it, and this wire would hook up to a computer controller. And the reason they call it a stepper motor is because it moves in very small increments which can be controlled precisely, as you can see. And what these motors actually would do is they would drive the screw. There's a long threaded rod screw which goes underneath this track all the way, and when you turn it, it will in turn pull the track along and move your camera in very precise increments. So it's kind of hard to see when you turn it so slowly. But in an animated shot, you would do this a lot quicker, or it would appear to be a lot quicker of a move if you wanted it to be, simply by turning or controlling the threaded rod. Let's say spinning it 10 times per frame or so. So I'm going to go through all the parts that make up one of these types of rigs, so maybe you can build one yourself. And something like this costs probably around $35 to $50, depending on where you buy your parts. And I actually used almost throughout this whole thing, I used scrap wood, and the most expensive part is probably the threaded rods. Okay, here you can see the track setup that I've used, and it consists of a bearing which is inside here, which I've glued on into a piece of this wood here, and the threaded rod is epoxied into the bearing and it spins freely. Now the track is just a pair of aluminum tubes, which I brought at a hardware store and cut in half to make up this track. So we have metal, wood, and the handle, which I've actually created from a piece of plastic here, is just simply glued on to turn the rod. And this rod controls the entire camera assembly. When you spin the rod, this threaded nut here, if you can see, has this piece of angled metal soldered right to it. So when the threaded rod spins, that nut grips the rod here and will move along like this. And since this piece of angled metal is soldered onto it and attached to what the camera is sitting on, it's going to pull this entire assembly along the track. And since the threaded rod has equally spaced threads, you can actually move this really precisely. So that's how the basic premise of this works. And it looks a lot more complex because I have other things attached. But it all works on the same principle of, we have a threaded rod connecting to a handle which we can turn. And this here, which is just a long nut which had more angled metal soldered to it to connect to the bottom, pushes the rod up through a hole, as you can see. It pushes that ball bearing, which is soldered to the tip of the threaded rod, up. And since this is on a hinge, we can precisely move the camera, see here, in an up or down manner like this. And also what I've done is I've attached the camera onto this box, which has a swivel right in the center. And when I want this camera to move like this, I have more threaded rods which I turn. I loosen one and tighten the other like this. And it will turn the camera. One final thing that I want to discuss before going on to the next subject as far as motion control is what we're actually doing with the camera is animating it. So for example, we have our camera set up, and if our lens is on a subject here, and then we want to have the camera move over to a subject or a puppet over here, you need to actually move the camera in increments so that it can be from one subject to the next within a certain number of frames. And we're going to discuss timing later on when we're working with the puppets. But I just wanted to show you a trick that Chris Endicott taught me on the phone a long time ago with regards to spacing out your camera over a period of time and moving it in equal increments. And as you know, the threaded rod already will move this camera in equal increments. But if you're going to be spacing things out throughout the shot, from, like I said, one subject here to here, and then maybe a third one over here. So the camera has to move in 3 positions, but you don't want them all, you don't want the camera to move in one straight smooth line. So maybe you want the camera to move from the first subject to the second subject really quick like this, and then to the third subject real slow. You had to space it out differently. So the way you do it is you first put your camera in the first position, which let's say is here, and then we know we have to move the whole entire camera body over on this track a certain distance, and it's going to stop, and it has to move again. So the way we do it is we hang this large piece of poster board, which you can buy in office supply houses and whatnot. And there's two ways to do this. You can take a laser pointer and stick it next to your camera like this and secure it there and press a button so that it shoots the laser pointer right, let's say on this spot here. So when you move your camera, that laser will move and correspond on this area behind here, depending on where the camera is, because it's going to be shooting that angle out. But the really cheap way to do it, which is how I'm going to show you, is to take a long dowel rod like this and butt it up against your camera and then push it straight back until it hits the foam board. And the next step is to take a marker and to make a mark on your poster board like this. So we have a straight line along the camera path to the foam board. And now we're going to take the camera and we're going to move it to the next position, which is, let's say, to the right. I'm going to try to do this quickly. You can see it might take a while to do this, but the whole thing is you want to plan out ahead where your camera is going to be before you actually commit to, your animation, because you want to have this thought out as much as possible before you animate. And the reason for that is because you want to concentrate on animating your puppet instead of having to concentrate on moving the camera too much. So now you can see that we've moved the camera and our pointer is changed position to here. So we've lined the camera up on our second subject and the first subject, and we know that the distance between those 2 points is this. And the third position is going to be even further over. So let's say we move the camera over and our dowel rod now sticks somewhere over here. So we'll make our third mark right there. Now we know, let's say, that we're going to be shooting our animation at 24 frames per second. And we're going to say that, well, we want it to take 1 full second to move from here to here, and we want it to take 1/2 second from here to here. So what we're going to do is we're going to say, okay, half of 24 frames, we have 0 frames, 24, and then half of 24 is 12. So that would be 36 frames total. So 0, 24, and 36 frames. So we can space it by making marks in between those two dots. So we know that halfway between that dot and that dot will be 12 frames. And then we know halfway between 12 and 0 will be 6. And then halfway between 12 and 24 is 18. And you can further break it down into individual frames. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. And you can take your pointer and accurately move the camera along its path, which will correspond on your marks. And since the distance between these marks along here and here will be different. Your camera will go slow and then speed up. And the last thing I want to talk about is the fact that since this camera has the ability to move up and down, our pointer will also move up and down as well. And just to make a point about why it's important for this type of poster board setup is if we have a mark here, let's say our first camera position is here, our second one is here, our third position is here, and let's say our fourth position is here, you can draw a smooth curve between your points, and if your camera lines up evenly with this, with your pointer, you'll get a very smooth corresponding motion with the camera move. And you would simply break down your shot like this by making marks to correspond with the distance of your camera move. And you can actually make it even more accurate by taking a pair of calipers or a yardstick or a ruler or something that will give you the exact distance between points. So let's say it's a quarter of an inch. The next one would be quarter, quarter, quarter. And if your shot speeds up, you want to make sure that the distances are further apart. And you'll get a faster camera move. But that all, of course, depends, like I said before, on how fast you've timed things. If you want it to take, let's say, 3 seconds to move from your first camera position to the second position in its line, you would, make it the corresponding number of marks for 3 seconds here, and then the corresponding number of marks for, let's say, 1/2 second, and so on. And when you're doing these particular moves, animation principles apply just as much to these moves as with animating puppets. In this section we're going to talk about set work, and sets are extremely important for animation because a set like this has to support a puppet, which you're going to be animating obviously, and also props and the general environment that your puppet's going to be living in. So there's some basic rules that you need to understand before you can animate a puppet, and obviously since your puppet is going to be attached to the set, you really have to make sure that everything on the set is secure, and also that you're able to reach a puppet easily, like this guy here, and that nothing will shift or change place or shift like props and whatnot on the side, because if you're animating a character and props and things start to move around, it'll actually look like there's an earthquake going on, which is not really desirable, obviously. And sets are constructed using lumber, like 2x4s, to create some legs, and the legs are attached to, of course, the set base, or the floor of your set, and the walls, and in some cases you'll have rigs and things which might be attached to the outer beams. Let's say a flying rig which is attached to the side and comes up. So a set really is incorporated into the entire process of bringing characters to life. And so a lot of thought has to go into building a set before you can even consider animating a character, because if your set is extremely flimsy, it's going to reflect your animation of a character. So the first thing um, is obviously the height. And the height of the set comes up to about my mid-chest area, or maybe the top of my stomach, I guess, which allows me to come in here and with my animation camera set up sort of where I am here to my right, it allows me to come in here and not have to be hunched over like this or having to reach up. Everything is sort of very convenient for me to grab. So a set should be somewhere around 4 feet tall, or just the height of where you're comfortable working, where you don't have to physically contort your body to get to a puppet. And as I said before, you're going to use 2x4 construction and wood screws, or actually drywall screws, to secure pieces of wood to each other. And a set like this is probably going to cost, let's say $30 to build, just the framework and with the screws and whatnot. So that's sort of the basic rules of set building. Is the height is important. You want it to be secure and sturdy. And I'm going to show you sort of some things here and go around and show you in detail some more of the specifics, because a set like this looks sturdy on the surface, but there's always problems that you encounter when you first build a set. Okay, here you can see our puppet set up on our set here, and you also see our props. We have a clock and a lamp. We have a log in the fireplace. We have a prop here on the floor, and we have also a table. We have a door, and we also have the set floor, which is lying on top of our 2x4 construction. So what are the first problems that most people encounter would be bumping the set. Now I'm going to tap the set here on the side, and you'll see what happens. Obviously that's not a good thing, so but that's something that can happen and actually ruin a shot and cause a lot of problems, especially if any of these props are in the camera view. So the first thing you want to do with any set is you just want to make sure any props are either maybe hot glued or crazy glued, onto all the walls, if that's where you have them set. And something like this should be also secured. And our door here, which we shook the set and it didn't fall out, luckily, but as you can see there's nothing really holding it on. So pretty much anything that you have on the set you want to make sure is glued or secured. And with regards to the set floor, see, it's not screwed down or anything, so you want to make sure parts like the set floor are attached to the framework of the set, which is very important, because these parts can shift, and if your puppet is secured to the floor and the floor shifts, the entire puppet will move. So everything that a puppet is on has to be completely secured. There's no getting around it, really. And with regards to the framework here, you can see I have a simple frame which goes right up to the set floor. And there's some problems that you'll encounter with this as well. A lot of the times on the floor here, where the legs meet the ground, there might be a gap. So let's say, for example, there's a gap right under here. Anytime that you lean on the set, the whole set's going to move down and up. And the way you fix this is you get some wooden shims, and these shims cost maybe $1 for 50, and they're just a simple wedge. As you can see, it tapers down. Then you want to stick them right underneath your set, these legs, if there's a gap. So like this one here's got a gap. I'm just going to slide it under there. That's pretty secure actually. But if you have any gaps, you want to make sure that you get a shim right under there. And then you want to test it by pressing down on your set, making sure it's solid, doesn't shake. And that's another problem which you can fix easily. The other thing is we had this light stand right up there aiming onto our puppet, and there's wires obviously coming out of here and being connected to our little outlet here or whatever. And one of the problems with wires, of course, is if they're connected to a light and you kick a wire here when you're trying to animate, you can physically move your light and again ruin the shot. So the light has to be secured, or the wires have to be maybe pushed under your set. And if you have no choice but to put a wire where you're going to be walking, you want to make sure that you take some duct tape like this and just tape right over along your wire so that you can't physically move it. And with regards to the floor itself, you want to make sure that the floor is obviously not a carpet. With a carpet you would have a lot of rocking of this set. Your lights here would rock. You couldn't tape your wire down. You couldn't use shims. So you have a lot of problems with that also, with carpeting. The other thing you can use is a wooden floor, which is second best. Wood or tiled is okay. And that will work good for your set base there. And finally, one trick you want to do with regards to the set is you want to take wood or something and prop it underneath. You want to take maybe some old paint cans and just set that on the wood all the way across underneath, or any other like books, any kind of heavy objects, to weigh your set down. And weighing your set down will reduce the amount of vibrations. If you bump the set, it won't slide across the floor as easy. So adding paint cans or books, filled paint cans of course, will help a lot. So that's pretty much the very basic set layout. And the set floor itself obviously has to be made out of wood, but there's a lot of different types of woods to choose from. And the main purpose for using wood is because you want to drill through it for the use of what are known as tie downs. And this here is a simple tie down, and it consists of threaded rod, a thumb screw which slides up and down, and usually just some sort of plastic cap or something to grip the threaded rod from below. And now this threaded rod is what actually holds up a puppet from falling over on a set. As you can see, this puppet here is just going to wobble around, and for animating any sort of movements, you want to make sure that his body is secured to the set. And we have holes which are threaded and into 1/4 inch aluminum stock, and those holes correspond to the threads in the feet, of course, correspond to the threads on the thumb screw. And the thumb screw goes up underneath the set, and this part screws into the puppet's foot. And then when you push the thumb screw up, it hits the wooden set floor from beneath and pulls down on the foot, which is connected to the threaded rod. And we're going to kind of get into that later on, and I'm going to show you some demonstrations. But for the set 4 construction, one last thing you want to consider are the types of woods for creating the floor itself. Now here we have some very cheap plywood, which is more or less like a hobby plywood, and it has a few layers. Let's see if I can get it in focus. So there's maybe 3 or 4 layers of wood to make up this very cheap plywood, and you can see that it splinters really bad. And now this part would be the bottom, the parts which splintered, because you're going to drill through the top of the set and down with a drill to make the holes to insert your tie downs. So this thin plywood is really junky. As you can see, it splinters, and when you try to insert the thumb screw through a hole like that from below, you're going to run into a lot of problems. So thin plywood's not so great. Then we have some, I guess this is about 1/4-inch plywood here, which is also made up with about 3 or 4 layers. And here's the top of the set, and here's below. We've drilled a hole through the top, and it came through and also kind of splinters like this. And that's a little bit better than the last stuff. But when you try to insert your threaded rod through the bottom, those little splinters can get in there and stop that from happening. So plywood isn't so great. And then we have this sort of splintery, well, not non-splintery particle board, which is made up of glued sawdust. And this stuff is actually really inexpensive, and usually you can get it with a veneer on the top in let's say 4 foot by 4 foot sections, or 2 by 4, 2 foot by 4 foot sections, and it's really inexpensive. And it's just made up of really tiny particles, as you can see, which are compressed with a glue mixture added to it. So when you drill through this, no splinters occur, and when you're feeling around under here with your threaded rod to push it up through the set floor, you don't have to worry about splinters causing any problems. So that's just something to keep in mind for making set floors. So you want to use this type of wood, and you don't want to use plywood, which I used, unfortunately, this is an older set, so I really didn't know what I was doing. These are armatures, and without armatures, you have no way to control what your puppet does during animation. And here we have several types of armatures used for puppets. Now, we sort of promote on our website using this type of armature, which is aluminum wire and epoxy. And this one here is an older one, which is actually slightly incomplete, but that's an aluminum one. And these here are lead wire and brass tubing armatures. And these here are actual armatures that were used for Will Vinton Productions in Portland. And these are actually probably over 20 years old, these armatures. And when Will Vinton coined or trademarked the term claymation, many people have never heard of Will Vinton Studios, but they're actually the company that came up with the term claymation. And these armatures were used exclusively for a very long time, over 20 years. These types of armatures were used. And they're a more complex armature to make. And if you want instructions and diagrams, actually, we have all that in our ebook, Secrets of Clay Animation Revealed. And then the last guy here is a ball and socket armature. And this particular armature consists of machined aluminum and drilled out ball bearings which accept steel rods to connect the ball bearing to different aluminum parts, such as like the hips and the shoulder connection part, which is just a series of holes drilled with, and the holes are tapped with a tap set, and then small, what do you call those exactly? They're, I forget what they're called, but they're just little, I guess, threaded set screws, which will go down through the aluminum and tighten down on top of those rods to hold them in place. So these are the different kinds of armatures, and the most common one you'll find today at most studios are the ball and socket type, and that's because they're more professional. You can use them for a longer period of time. I mean, once you've built one, it will last forever almost. So it's almost economical to create these kinds of armatures for studios. Now for clay, depending on the type of armature you have, clay, of course, is different than foam latex. And foam latex is used, excuse me, on more or less for the ball and socket type armatures, but the aluminum type, which we actually promote because it's the simplest to make, and it also works well for hobbyists. As you can see, when you move it, it has a springiness to it, and it actually springs back into place. So when you move an arm, for example, like this, you have to actually flex it past the point where you want it to end up during animation. And let's see if I can show you a side view, you can kind of tell. So when I move his arm up where I want the arm to be, I have to move it past that point so that it springs back. So the arm is moved up further, but I had to move it about here in order for that to work. And I'm just going to show you a quick demonstration of how to use a surface gauge. And for these types of armatures, surface gauges are extremely important to use because there's no other way to accurately tell how far you've moved an arm. And so what we have here is a surface gauge, usually used in the auto industry, and any sort of machine shop usually has these. And you can buy them for about $20 on eBay, ebay.com. But I'm going to get into that later on, but I just want to show the amount of memory in this aluminum wire is so much that I want to move this arm, let's say, 1/4 of an inch upwards. So I'm going to grab this puppet and move the arm up. Let me zoom in even further. So we have our surface gauge, which is just a point of reference in space. So we put that point about the center of this guy's hand. And now I'm going to move his arm up about there. And see, it pops back down slightly. So what you have is now you know exactly how far you moved a hand from the point of that surface gauge in an upward position. So springiness is countered by using surface gauges to see exactly how far you've moved the hand. And we're going to move it again here just to show you once more. Now I'm going to move this arm upwards, and I want it to be about 1/4 of an inch further up, but I'm going to move it past the point and let it spring back down. And then, you can adjust it by looking how far you want it by just tapping it or whatever. So aluminum wire is one of the simplest ways to make an armature, and it's the most affordable, and it works really well. I mean, a lot of people think, well, it's aluminum wire and it's cheap, but aluminum wire actually does work really good. And now we're going to look at the Will Vinton production armatures, which are, I mean, these are so old, but you can see they're still intact, and they've been stripped of their clay. But one of the benefits to lead wire and brass armatures is the fact that there's almost no memory. And no memory is of course good, because once you move a puppet's arm and you move it exactly 1/4 of an inch, you know you're going to move it exactly 1/4 of an inch, because it's not going to pop back, let's say, 1/8 of an inch, because of memory problems. So we'll put our surface gauge here on this guy's arm, like such, and we're going to move his arm up about, well, actually we'll move it down this time, and we'll move it about 1/4 of an inch. So I'll move it, and you see that it moved, but it didn't spring back. So lead wire has no memory, and it works just as well as a ball and socket armature, except sometimes the lead, when you bend it a real lot, it'll actually end up breaking. But you construct these in such a way that you can actually replace a broken part in the middle of a shot using a system of set screws and nuts. And the nut, there's a hole in this brass tubing, which the nut is soldered over, and then the set screw is screwed through, and it squeezes down on the arm, which is plugged in. See, the brass tubing of the arm socket here is actually smaller than the brass tubing on the outside, so you can slide that piece in, and when you slide the shoulder here inwards, that set screw is tightened down using a hex wrench, which is just a hexagonal piece of metal, basically. And the hole in the set screw matches the hexagonal shape of the hex wrench or screwdriver, hex screwdriver, and we'll tighten that down. So if this arm were to break, we can simply take it and just pop that right out of there. Just yank that out, and then fix the wire and plug it right back in. So that's just a simple explanation of these types of armatures, which you might actually, if you're doing a clay animation piece, let's say for Will Vinton Productions, they might actually use this type of system, even though it's considered an outdated system. But they really don't, actually most studios don't really use all clay characters anymore. It's sort of something which, I don't really know why, but it's just not as popular. So this sort of knowledge is, is sort of fading into the past, and not too many people know how important this is. And one thing I want to show, if I can here, are these puppets' feet. And the feet on these characters, on these armatures, are, you need to use a wooden floor set with these particular characters. Let's see. You can see that a foot is actually constructed in such a way that we've taken a piece of brass stock and taken, let's say, a small grinder or a Dremel cutoff wheel and cut a notch into this brass stock. And then what they did is they soldered the brass tubing onto the foot, which has a plug-in ankle joint. And then what they would do is they would take the wooden set and probably drill, let's say this piece of wood is a set, they would just drill a hole into the set where they would expect the foot to land during animation, and then they would just insert a small wood screw right through the foot and then cover it with a shoe, so the shoe would cover up that screw and you would never see it. And the reason we know this is because you can see that this one foot here has the remains of one of those feet. and they actually used hardening like Sculpey clay or Fimo or something to make the shoe, just for the back area there. And then they used the softer clay, which they could smush down over that. So anytime the foot would move or the foot would land, they would remove the soft clay shoe in the front, screw the foot down, and then add that shoe right back on there. So that's how they would make a puppet walk, by holding it down using that system. And it works really well to do things that way too. I mean, most people think that sounds impossible, but here's our aluminum armature here, which we built. And we use the same system, except we just use a loop of the wire to hold the foot down. And of course, it takes a lot more time to do things this way, for a puppet to walk. Now, the last type of armature is the ball and socket armature, which is used a lot in modern films. And the first ball and socket armature that I know of anyway was made by a guy named Marcel Delgado for the movie called King Kong, which of course is a popular old movie. And one of the things with King Kong and the way that armatures were made was that the joints were made out of steel, and nowadays they're made out of aluminum because it's easy to machine all these parts. So, but steel is something that has to be used for clay characters, because what ends up happening is oils will get into the sockets where, let's see if I can show you. Now, the way it works is these two pieces of metal squish down on top of this ball bearing to make it tight enough to where when you move this arm, it'll hold its position. So once oils get down into there, what's going to happen is that's just going to loosen up and sag and flop down like a noodle or something. So with clay, when you add clay over a joint like this, you have to make these parts out of steel. And usually what they'll do is they'll make a sandwich joint where you just drill a hole straight through a piece of flat stock, let's say here and here, and those two holes will be the socket for the ball bearing. And so that's just a simple explanation of what is usually done for when you add clay over an armature like this. Now, one of the ways that is also a modern way to make a puppet walk is to take, let's see here if I can get the lining correct, is to take a foot made out of something like aluminum and to drill holes and to thread them. And what are these threads for? The threads are for what are known as these tie downs, which I think I explained before. It just consists of a threaded rod and a thumb screw and an end made out of epoxy or plastic to grip. And then we're going to take our 440 threaded rod with a 440 thumb screw and push it up through one of these holes. So you see that this threaded rod is extending really far, and we only need it to extend about as far as the thickness of the foot, so we're just going to go like this, and we're going to push this up through the bottom. And the trick is to take and push that threaded rod through the hole which we've tapped. And once you've done that, we're going to show you in a second what that looks like. Okay, so underneath what we did is we just attached that threaded rod and screwed it right up into that hole. Right there. The threaded rod, let's see here. You can see the threaded rod just came right through the top, like that. So the trick to actually securing this foot to the set floor, all we have to do is go underneath, and you can see there's our thumb screw, and you can see the foot above on on top of the set. So all you do is you just tighten that thumb screw like this until you can't tighten it anymore. And then you come on the top of the set and you can see that our puppet here is completely secured to the set floor. It's very solid. I mean, you can make this puppet, you know, kick. You can make him do whatever you want. And that foot is going to be dead solid. I mean, you won't be able to move that at all. And the only thing that determines how solid that is how tight you tighten that thumb screw underneath. So that, you know, if you tighten it really good, you know, that's not going to move at all. Okay, in this part of the video, we're going to talk about using surface gauges and also how to time a shot. The distance between an object in between frames, and also the number of frames per second determine the speed of an object. So if we were to have take a picture of this piece of red clay right here, and we were gonna film something at 2 frames per second, and we move it this far for our second frame, that means that in 1 full second this is going to move from here to here. So it's pretty simple how that works, and it only gets more complicated when you start to get into higher frame rates, and the standard is 24 frames per second. So as I had mentioned before, persistence of vision, this is an old flip book, persistence of vision is what makes something appear to move over a certain number of frames. Now with this flip book, I can actually, by flipping it at different speeds, get a different frame rate. So let's try something around, let's say 4 or 5 frames a second here. Something like that. And at 24 frames a second, it actually goes pretty quick, like this. So depending on your frame rate and the distance between one move and the next determines the speed. And since your brain retains, just for a fraction of a second, the image before it, it looks like he's actually moving. Well, how can you explain it? When you say the word 1001, that's pretty much, it's going to take 1 full second or 24 frames to say 1001. And Anthony Scott, on his website, I asked him, you know, how do you time your stop motion? Because not too many people talk about it or know about it. And Anthony has been animating for, you know, for forever, working on Gumby and Nightmare Before Christmas. So, you know, I figured he'd be the guy to ask for timing, and he gave me this little trick where if you say the word 1, it's going to be 6 frames. 1,000 is 12 frames. 1,000 is 18 frames. And of course 1001 is 1 full second, which is 24 frames. So we have a quarter, a half, 3/4, and 1 full second based on just saying these particular words. And it's really simple how that works, and it's kind of, you know, it seems so obvious once you know, break the word 1001 down 4 times, you know that it's going to be pretty much as accurate as you can get just by using what you say as a timing method. So you don't need any kind of stopwatches or video reference for this. You can just say the word and know how fast something's going to move. And as an example, what I mean by this is, let's say we're taking this here, and I'm going to put the surface gauge here, right where this little point is on this red ball of clay. Get that thing to stay. And I want the starting position to be, let's see, I want the starting position to be right where this point is, and the end position where this point is. Now, just by looking at it, I'm going to move it like this. Okay, now how long did that take? Well, the way you figure it out, you put it back, and we say 1001. Okay, so we know that it's going to move this fast, 1001, and 1 full second, which is 24 frames. Now if we say the word 1, so we can do it again here, 1, we know that it's going to be 6 frames, and it's going to move about this fast. 1. Now, let's say if we wanted to take 3/4 of a second, we can say 1000, 1000. So we know that for it to move at that speed that you just saw it, at 24 frames per second, that's going to take 18 individual moves between here and here for it to move at that speed. So if we say the word 1 and move it, 1, it's going to move at that speed, and it's going to take 6 frames to move. So I'm going to show you here how we're going to plan out a move of this guy's arm in an upward motion. And it's a pretty straightforward thing to do, but I just want to kind of show how exactly you want to document and time this out. So now what I have is, of course, a puppet, which is sort of like a human-shaped puppet, and we want his arm to move up. His arm here, maybe up like this or something. And first we want to time out how long it's going to take. So going back to our trick with our 1, 1000, 1000, 1001, we're going to figure out how long it would take just for a guy's arm to move from one position to the next. So the way we want to do it is just take our own arm and just move it up. So we go 1000, 1000. So 1000 seems to be, a comfortable thing to say while I'm doing that, I guess. And when you say 1000, that means that we have to move an arm within 12 frames from position 1 to the last position. So 1000. So we know that our puppet's arm is going to be up here, and it's going to start down here, and it's going to take 12 frames. So how do we go about doing this? And as in a professional way, if you get a job doing this, you'll get an exposure sheet. And exposure sheets are just a simple piece of paper with lines and numbers drawn on it. You can see that. It's really hard to see because I printed this particular sheet out with really tiny numbers so I could fit a lot on one page. But what we have are just lines, and each one is numbered. And on this page we have 0 through 48. And you can use loose leaf paper, notebook paper, anything that has lines that you can number from 0 to however long your shot is. And I have a couple of pieces, or 3 pieces here. And this goes up to 101 frames. And you can see that when you work something out, you can draw these curves to sort of block off sections of frames. So for example, we have this puppet here and we want his arm to move from one position to the next in 12 frames. So we would look at our exposure sheet and look for, frame 0 through 12. And what you would do is you would just take your pen and draw a curve from 0 to 12, like this. And then you would mark along the side, arm up. Now, since that only takes out 12 frames, we can actually plan out hundreds or, just tons of moves with one character, like this, and block it off on an exposure sheet. So let's say we want to have a blink while he's moving his arm up. You would go something on the other side maybe. Let's say the blink took 3 frames. You would draw a curve from 0 to 3. Oops. Something like this. 0 to 3. And then you put along the side, blink. And then let's say halfway through moving his arm up, his other arm moves another direction. Let's say his other arm starts to move up on frame 6, and it takes 12 frames. So you go 6 to you count down 12 frames to 18 and draw a curve. 18 is here, so you just draw 6 to 18, and along the side you would say right arm move up or something, just so you know what each thing is going to be doing. So that's how you use an exposure sheet. And a lot of times you'll get into a studio and they'll hand you a sheet like this, and it will have letters, and the letters correspond to a voice track of, let's say, a voice actor who's previously recorded his voice, and they've broken it down on exposure sheets, and we're going to talk about that later. But for right now, we're going to concentrate on moving this guy's arm from one position to the last position in 12 frames. So all we really need are, well, technically you only need one surface gauge, but I'm going to go with 2 gauges, one which I brought and one which is homemade. And I'm going to start off by taking the first gauge. Let's zoom in on this guy. Now, I'm going to have to come in here and grab this puppet while I'm moving his arm. And the reason why is because I don't want this armature to move really far forward or sideways, or because when I'm pulling on this other arm, it's not too sturdy. And I mean, I could make it sturdier by tying down his other foot. I've only got one foot tied down right now. But just as an example of how to protect yourself if you have an armature which is a little bit flimsy, is you take your second surface gauge and you want to stick it where the point of your gauge is touching a reference point on this puppet's body. Not actually touching it, but where the tip is almost touching it, very close. And now, for example, if I were to bump this character, whoops, okay, I goofed up. I know that at the point where this surface gauge was, I can move it back where it was, and it'll be pretty accurate. Now his head moved, so that would actually ruin a shot if I did that, because his head's kind of loose on here. I don't have it tightened down well enough. But as far as his body's concerned, if I had bumped his body, I can move it right back to where the point of the surface gauge is, and it would be really accurate. So usually that's how I do it, is I have a gauge which just is sort of a security gauge, I call it, because if you mess up, you can move it back to that first point, which is on this guy on his shoulder. Now, as I said before, we had to move this arm from the first position to the last position in 12 frames. Here's someplace. Here we are. So, I'm going to take our calipers and open them real wide. Here's our first position. We're just going to roughly see how far that is. So even more. First, last position. Let's say it's there. So that's about the maximum my gauge is going to open up here, as you can see. And we know that it's going to take 12 moves because we've said 1 thou when we moved our own arm up. So let's see, that's 12 centimeters actually, the full length of this gauge. So we know that every move of this arm from this bottom position to the top position is going to be 12 moves. And it's going to be 1 centimeter because the distance is 12 centimeters. And if you divide that by 12 moves, of course, that would be 1 move, 1 centimeter per move. So the little trick I've come up with is to take a piece of craft wire and stick it on the end of your gauge like this. You can see that I've looped it around, and now I've got this wire which, no matter which direction I twirl this, like this, the distance between the tip of the gauge and the wire is always going to be the same. See if I move it underneath like this? Doesn't matter which way I twist this. So I take the calipers, take the calipers, and I measure the distance between the craft wire and the tip of the gauge. And I want it to be 1 centimeter, so I'm just going to adjust it a little bit. Like this. So now we know that with this particular gauge, the distance between those 2 points is going to be 1 centimeter. And now I can twist the wire in any direction. It's always going to be the same distance from the point, as long as you keep, these two have to be lined up. And you can see it moves back and forth. But as long as these are lined up in this direction, it'll be fine. So getting back to the hand, if we're going to move this hand within 12 frames for this shot in an upward direction, we just take the first tip and put it on our hand. This isn't too secure here. There we go. Now we can just move the hand up to where the wire is, and then remove it. So that's a more accurate way to judge distances. And the reason you want equal distances of a puppet for each move is because equal distances mean that when you play the animation back, it'll be very smooth. Now if you don't have equal distances between the moves, what's going to happen is it's going to look like this arm might pop or jump really quickly like this. So you might have a smooth move like that, and then whoops, and then smooth again. So smooth, pop, smooth. And that's of course going to ruin your shot, because it might look like your puppet got hit with a sledgehammer in the middle of when he's talking or something. So I have a safety gauge on the puppet at all times. And the routine is you keep the gauge in there while you're playing with your puppet. Then you move your second gauge in, which has the equal distances marked out with craft wire of 1 centimeter for this particular move. And then you would put this gauge in the shot like this. Move the arm up to that point. Then you would remove both gauges from your shot, take a frame of film, then you would move it back and put your safety gauge on first to make sure that if you bump your character that you can move him back. And usually I just pick a high point on the puppet. The head would be an even better spot, really. But since it's a round ball, it's kind of hard to do that. Because it's, you know, if you put a reference point on a ball and you move it, it's really hard to move it back. So we put our safety gauge in, and we put our gauge in again. We move our arm from the first point to the next. Then we would remove both again, take another frame, put the safety gauge in first, move the point up again, move the arm up carefully from the first point of reference to the second, which is our wire. Move them again, take a frame of film, put the safety gauge back in, right on that point, put our gauge back on a point on the hand here. I just bumped it. That's not good. Move the hand up once more, about the distance you need, and if I need to, of course, now the arm is starting to curve, so I can move my reference point by twisting this wire slightly. Remove both. Take a frame of film, and you repeat this process over and over for 12 full frames. But once you've gone in here and you know the basics of this particular way of moving a puppet, just a simple arm in an upward motion, then you can really start to concentrate on other things. And for example, when I'm moving this arm up, I'm not really paying much attention to how far I'm moving this arm in this or this direction. So when I was moving this arm up before, I could have been moving it inward and then outward. I wasn't really paying too much attention. And when you get more advanced with, let's say, a surface gauge, not only do you want to look at, let's say I put the pointer here, I put my safety gauge in, I put the pointer here, and I know I have to move the arm up in that much distance between that wire and the point. You want to look at it from two angles sometimes. You know, you want to get in there, get your face in around here, and look at it over here. And you want to make sure that you're not moving the arm in a direction which is in or out. So you want to be really careful. And you want to move a limb like this in a curvy motion. And a design of the armature like this lends itself to curves because, you know, once you get to a certain point, the arm comes in, comes out. You know, you don't want it to be completely straight like robotic or anything, unless you're actually animating a robot. But that's how that particular process works. And it's the most basic way to do things. And I mean, the first films like King Kong used that process, but very crudely. I don't know if Willis O'Brien, who animated that, really understood how to get smooth motion very well. Because if you ever watched King Kong, which is from the 1930s, the puppet is very jerky. And like I said before, the reason for a jerky motion, like something smooth and whoop, and then smooth again, is not spacing things out equally. You can also, one way to time out, if you want this puppet to do something more complex, is to physically film yourself in front of a camera like you're, you know, I've got here, and act out a scene. And, you know, so let's say we have this character and we want him to clap his hands, you know, for whatever reason. You have a film where maybe he's an audience member, and the camera goes on him and he's clapping like this. And it's really simple, you know. It's really simple for a person to do. But what you can do is you can film yourself with a camcorder and then play it back several times, and then take a stopwatch and figure out how long is it between claps. And if your stopwatch says that 4 claps is 1 frame of film, 1 second of film, then you know it's 24 frames. 24 frames for 4 claps divided by 4 is 6 frames per clap. So you have to know math a little bit. So 6, 12, 18, 24, 6, 12, 18, 24, 6, 12, 18, 24. It's almost like music in a way. And, with animation, you're always working on a rhythm. And that's another thing that's important is you're never going to have a person clap like this. That's ridiculous. It's always, everything has a rhythm like a heartbeat. So what we got here is we've timed it out, and we're going to still go with the same thing where we've got 12 moves to move this guy's arm from here to here. So 12 moves, and we figured out it was 12 centimeters in length between those 2 points. So we know that 1 centimeter equals 1 move, and we've measured it out 1 centimeter with our calipers between the main point on our surface gauge and a piece of craft wire. So same thing as before, but now we have to calculate in here our easing in and easing out. Now if you remember our exposure sheets, over here, this line right here between frame 0 and 12, I drew a line, a curve, like this. And I wrote on the side, I said arm up, so I know that the arm has to go from one position to the next. And if we wanted to, we could even draw on here a guy, like a stick figure, like this. And then another stick figure with his arm up. And that way we can never forget what we're going to do here. It's drawn out. And now we're going to figure in easing in and easing out. Now for an arm move which is not very heavy, and he doesn't have any like heavy boxing gloves with like wrenches in there or something, we're going to just figure in 1 ease in and 1 ease out. So between frames 11 and 12, what we're going to do is we're going to ease out, and between frame 0 and 1, we're going to ease in. So what that means is that we're going to slowly move the arm in a small increment for our first frame, and when he slows his arm down, we're going to only take up 1 frame to slow down. So how we do that is we do the same thing as before. We put our safety gauge in, which is on a reference point somewhere high on this puppet's body. And remember, that's just in case we bump him. Then we can, let's say we bump him. Whoops. Okay, so we can move him back to where that gauge was, just in case. And now we're going to move this arm, and we put it in this first position here, the first pose, and we're going to ease in. So I'm going to take the gauge, and technically when you're moving an arm like this, you want the gauge to be on the opposite side, but since this is a demonstration and I can't be in front of the camera, I can't do that. But let's see if I can kind of maybe go like this. Okay, so I got my gauge, and I'm putting it right at the tip of his hand. Now it's almost touching here. And you can see my 1 centimeter distance for the wire here, but we're going to exclude that. What we're going to do is we're actually going to move this hand about that far, and that's our easing in. and we're going to move it in the direction that we want the hand or the entire move to go. And we're going to move the entire arm just a small distance like that. And we're going to remove this and then take a frame of film for our first frame of animation. Then we would move the gauge back in like this. And then it sort of screws everything else up because remember we figured it would only take 12 moves. 12 moves from one position to the last. But now we've only moved the first move about a half move. So, and we know that it's going to take about a half move on frame 11 to 12. So that leaves us with 10 moves. 10 moves until we ease out at 1 centimeter, which is what we figured. But we had to add a little bit extra distance between our craft wire and the tip because the distance will be actually shorter if we only moved it 10 moves. It'd only be 10 centimeters plus 2 halves is 11 centimeters. If you can understand what I mean, because when I eased in, I moved it half a move. When I ease out, it'll be half a move, which equals 1 whole. So that would only give us 10 moves at 1 centimeter, which is the distance between these 2 points, and that would give us 2 halves, which equal 11, and we want it to be 12. So what we're going to do is we're just going to move the arm a little bit past for our next move. So now we've eased in, and now we're going to move it at the full distance. So I'm going to take my gauge and put it back at this guy's hand here as best as I can. And now when I move this hand, or this entire arm, I'm going to actually move it slightly past the tip. Now it doesn't look like I am because of the angle of the camera. Let's see. Well, it'll look something like this. So instead of right there, which would be the tip of our wire, it's going to go a little bit past. And so for every move, we're going to move it just a little bit past our wire for the next 10 frames. Or what we can do is we can just widen the wire here just a little bit, like that. And then that means that for the next move, it'll be the same distance as when I moved it for this frame. So we'd of course remove our surface gauge. Whoops. Then we move our gauge back in. Move it up like this. Remove the gauge and do that 10 times. And that would lead us about this far. So once we get to this point, and we moved it 10 frames equally up, now we have to ease out because the arm has to slightly slow down. Because if it came to an abrupt stop, it would look really bad. That's because everything naturally moves by speeding up and slowing down, of course. So it's going to take our gauge. Oops. All right. Put the tip right on the hand again. Like this. And for our very last move, I'm just going to move this arm up. Let's see, it's kind of hard to tell the way the camera is, but it would look like this. Just a little bit from where it was before. And that would be an ease out. So what you'll end up with when you see your animation is a very smooth motion, and the hand would slow to a stop slightly, and it won't look very mechanical. If you didn't add those ease ins and ease outs, it'd look as though the hand went like this. You know, there'd be no fluid motion, it'd just be whoop, you know, like that. So easing in and easing out, very important. Now if you have something like a bowling ball or something where this guy's arm weighed 2 tons, you might have to double the number of your easing in and easing outs. Because, like I said before, if you were to blow on a bowling ball, it'd take 10 blows to make it move an inch, you know, really hard. Whereas a feather, you'd blow on it once and it would just fly off really quick. So a bowling ball would take a lot of frames to start up and slow down. And if I were to demonstrate on a piece of paper the distances, what I mean is it'd be something like our first move, second move, third move, which is further apart, fourth move, fifth, and you can see the distances gradually become further and further apart until you're up to speed, and then you'll have an equal distance of lines. And then to slow down, distance between like the first and second position of this guy's arm, if it were really heavy, would gradually become closer and closer and closer until it were to stop. Like that. So you would slow in, be up to speed about here, and then slow down. And that's the basic way of easing in and easing out. Alright, so we just covered how you use a surface gauge for your puppet to see how far you've moved a body part like an arm, and how you also use calipers. Now, that's the old-fashioned way to actually animate puppets. And nowadays what we have are digital cameras like this. This is actually like almost like a VCR camera, because you can actually put VHS tapes in this one. But we're not going to actually capture animation on the camera. We're just going to feed the line right through to a VCR to get a live image on a screen like this. And here you can see our puppet with the surface gauge in the scene. If I go in here, you can see me move it around. And a screen like this is really helpful because it allows you to see what your camera, in a general sense, will capture. So that, let's say we have a 16mm camera and we're going to be capturing on film. What we would do is we would line the camera up alongside the live image camera, which is what you see here. So, for example, if we had the film camera and you were looking through the film camera right now, we would put it next to the camera like this. And that allows us to have the same basic angle as the film camera, but using our video camera, which you can see the image on the screen. So what we do with our surface gauge, where we line it up and we take it and place it on an arm, something like this. Whoops. So here you can see we've got the point on a point on, or each point, a point from the armature lined up with the point on the surface gauge, which allows us to see the distance that we've moved that arm. Now on the TV screen, what makes this so much easier is you can take a pack of some alcohol-based markers like this. You can buy these in office supply stores, and they come in different colors. You got green, black, blue, and red, and you probably pay about $3 or so for a pack like this. And that allows us to actually draw on this screen. So for example, I'll take the red pen here, and I'll just draw roughly where that hand is, right like this. Now it doesn't show up too well with this particular setup because in order for me to actually film this screen, I had to have the screen pretty dark. But if you look real close, you can see there's a red outline right where that hand is. So what I'm going to do is stand over where my puppet is. I'm going to remove the surface gauge now. No surface gauge, and that means that when I look at my puppet here, I can't tell looking at the puppet how far I'm going to move this arm. But if I look at the screen while I'm moving the puppet, like this, now I can see exactly how far I've moved that hand from the first position. So moving a puppet around like this is a lot simpler and faster than putting a surface gauge in there for every frame and removing it. And that of course is going to give you a rougher animation actually, because you can only see movement on a two-dimensional plane like this. You can only see movement up and down and out and in, but you can't see from this angle, let's say, how far back I move this arm, like this. You can't actually measure that on a screen. So surface gauges still, even though it's old technology, still have a place in stop motion animation and clay animation, because you know, it's an advantage to use and will give you more accurate movements of your puppet. So for example, this guy here, I'm going to move his arm back roughly where that where I drew that first circle, somewhere around like this. And now what I've got here below is a video lunchbox, and a video lunchbox will capture single frames of animation and play them back. So that's what I have, but of course this is just for a demonstration purpose, so not many people are going to own one of these. You can buy one of these for about $1,000 used, probably, because they don't make them anymore. But the newer models are around $3,000, and because of that, we don't really recommend you buy one, because there's cheaper computer programs out right now which will do the same thing. So this particular guy here, I'm gonna capture a single frame, and then I'm gonna move him a little bit. Now I'm gonna compare where he was before and where he is now. So that's what a lunchbox does, basically. It shows you how far you've moved things. You can download a program called Animate, and it'll actually do this. It'll show you where your puppet was before and where it is now. But if you don't have a computer and you can't do that, and you don't have one of these, just drawing on the screen like this is one way to do it. And every time you move a character, you have to redraw where that part of that body is that you're moving. So I'm going to take a different colored pen and just draw an outline where the hand is. I'm also going to capture a single frame on my lunchbox here. Capture a frame. And now I'm going to move the puppet again without a surface gauge, just by looking once more. And so we've got first position, second, and then the third position. And you can see that you can space things out like this. Now I'm going to take a green pen and I'm going to draw an outline on the hand here. And I'm going to capture a single frame of film, or not film, just a digital still image. And I'm going to do the same thing here. Move his arm up once more. And I'm going to make an outline this time with a black pen, like this. And that's the process of, let's see, now there's a first position, second, third, and fourth. And I'm going to take a still image. And that is how you space things out. Like this guy's hand, for example, is the same width. And when I make an outline, you can see that the width of the hand is what determines the spacing of the moves. So drawing on a screen like this will help you to visualize easier the path of motion that your puppet is going to take. And now this guy here, if we want to move his other arm here, what we can do is we can draw, let's say, an arc with our alcohol-based pen. Draw an arc here like this next to his body, and we can roughly space out on a screen like this. Let's say we figured out that we want this arm to move from where it is there to there in 6 frames. What you can do is you can look at this line and figure out about where the halfway point is and draw a line like this. So that would be 3 frames, and then break it down even further. So 3, 4, 5, 6. So you can draw a line there, and draw a line there. You know, roughly where the middle of that is. And you can even take a tape measure if you want to get really technical, and measure the length of this curve from that position to that position, and divide it by, let's say, 6 frames, which is what we want to do. So that's sort of what we would do with the surface gauge. Is we would first figure out the first position of an arm with the surface gauge, and the last position of an arm, measure it with the calipers, and divide that distance by the number of frames. That's the old-fashioned way to do it. And here we have a more modern way to do it, which is a lot simpler because everything is right on the screen, which allows you more flexibility, and you don't have to bump the puppet around by measuring and whatnot. So it's just a great way to go. And a surface gauge, like I said, is still useful, where you can use it as a safety device in case you bump your puppet, let's say forward or backward, like this. If you have a gauge there, it's still helpful because you can move that puppet back to its original position. And the same thing goes with when you see a live image on a screen. Whoops, there's our live image. What's helpful is if I were to draw an outline of this arm with the pen, or even just draw a line there like this. If I don't ever want this arm to move when I'm animating, let's say his other arm, I can just draw a line there, and if I accidentally bump this arm to the side, whoops, well, if you bump your digital camera, that's not going to be good. But if all I would have to do is just take his arm and put it right where it was. So that'll save you from more problems as well. Okay, here we have a puppet which is obviously not 100% completed. You can see one of his eyes is missing, or the pupil, and the first thing I want to talk about when taking a puppet that you've sculpted is I want to talk about the eyes. And the eyes are the single most important part of the puppet, for the reason that when you look at a puppet while they're being animated, your own eyes are normally attracted to the puppet's eyes. And the other reason is that puppets and their eyes are the most expressive part of the puppet. So there are some problems with animating round eyes. A lot of people think that all you do is take a piece of white clay and stick it on there. And in fact, that's not true. At least not for like Wolverton Productions, who coined the term claymation, and actually they're the first people, I think, to use plastic eyes like these. And these are Delrin ball bearings, which we sell these on our site. They're 5/16 inch Delrin ball bearings, and they're hard, so you can't dent them, even if you're animating and you hit it with your tool. And you actually have to modify the eye to make it where you can animate it. And the way we let's see here if I can zoom out. The first thing you want to do is you want to take a flame of some kind, like a lighter, or let's see, we got a tank of propane here, which of course these things are pretty dangerous. This piece here you buy and you screw it onto a tank of propane like this. And this particular tank of propane is for like camping stoves, and obviously propane is a fuel source, and you can see just by the label that, you know, extremely flammable, and it can explode, and breathing the fumes can basically kill you. So of course, when I show you this stuff, if you're under 18, you probably want your parents' permission to use something like this. But what the next step involves is modifying the eye, which does not have a hole. And you need a hole in our plastic eyeball in order for a pin to be inserted, which we have, just a small pin. And we had to somehow get this pin inserted into the eye to move it around in its socket. So I'm going to just demonstrate roughly how you do this. And like I said before, it's extremely dangerous to be playing around with fire, so you always want to have a cup of water, just in case I burn something here and it catches on fire. And also, if I were to singe my finger with the flame, I can stick my finger in there real quick. Which I don't expect that to happen, by the way, but just in case. So we're going to take our propane, and we're going to turn the knob and let the gas escape. And we're going to hold our lighter up to here so that a flame comes out. And we're going to put it really low because we don't need it really hot. And we're going to do two things. Whoops. We're going to take our straight pin, and we're going to take these metal pliers here, which are locking pliers. And these have a little mechanism where it's got some teeth, like a ratchet, that allows this to stay closed without me keeping my fingers in there like that. And we're going to take the tip and we're going to stick it in the flame like this until it gets nice and bright red. And I'll show you here. You can also do this on a gas stove if you want to. And you let that tip get nice and red hot. And once it glows like this is when you want to take the tip of this pin and we're going to insert it into the eyeball. Let me zoom in. Okay, so there we got our guy. And right now I'm going to get this nice and red hot. And the pin only stays red hot for a short period of time because it's so thin and it cools off really rapidly. I'm going to take that and jab it right into his eye and push it in and kind of wiggle it a bit. And what that's done is it's melted a small hole into the plastic Delrin ball bearing, which once you melted that hole and pull the pin out, the plastic then re-hardens. And sometimes it takes a few jabs too to get that pin in there nice and deep. So I'm heating the pin and I'm sticking it in there and pulling it out. Now this is a method that I came up with because a lot of my puppets have really small pupils, and because of that I don't have any drill bits which are small enough to drill a hole where it's barely noticeable. So I use the pin method. And the other way to modify an eyeball like this, which is a little bit safer of course, is to take a file, a small file, or a piece of sandpaper, and sand a flat spot on the eyeball. And once you have a flat spot, you can then take a drill with a small drill bit and drill a hole right into the eyeball itself, leaving a hole. And that of course is another way to get that hole in there. And now that I've got the hole, and I'll show you on his other eyeball what it looks like. I can stick the pin in like this, right into that hole, and move this eye in a different direction like this. So that's how you physically animate the eyeball and make a character look around, is by sticking a pin right in that hole that you've melted and moving the eye around. And so once you have a hole or drilled or melted in there, you have to paint the rest of the eye around the hole. And one type of problem that you might encounter if you use acrylic craft paints is the eyeball can actually scratch off really easily. The paint just sort of doesn't have a good, doesn't stick on there really well. So what you have to do is you have to use Testor's enamel paints, and these are really inexpensive paints, and the particular color of this right here is rust, which is really just a brown color. And we're going to take this and paint right around that hole and even inside it with this paint. And the enamel has a less of a tendency to wear off of your Delrin ball bearing eyes. So since this stuff's going to come off anyway, we're going to stop the tape and we're going to clean that off and repaint the eyes with rust enamel paints, and then you'll see what we do next. Okay, I just painted our character's eyeballs with enamel paints. So his eyes are now ready to be animated, and the enamel paint we know won't chip off during animation. And as you can tell, he looks kind of creepy because he's kind of got no eyelids or anything. So he's kind of got this sort of bizarre, frightening gaze. But since the enamel paint is in the process of drying, I'm gonna show something which I recently got this original California raisin puppet, and this is a puppet which is probably 10 years old. I mean, or maybe actually older, more like 11 to 13 years old, and it's in really bad shape, as you can see. The clay itself has been mangled and pushed around and, you know, beat up basically. But I just wanted to show something which I learned as far as clamping your character's feet down during animation. And one thing that I always had thought was that you would take a wood screw or a small sheet metal screw, like a Phillips head screwdriver, and use that to hold your puppet's feet down. And I think I actually showed that before. And one way which I had never seen before until I got this was using these hexagonal machine screws. And these are 1/2 inch long machine screws, and they're called, I believe, hexagonal cap head machine screws. And they take an Allen wrench, or I forget, I think they actually call these keys for some reason. But it's an angled piece of metal which fits into the hexagonal cut in the top of the machine screw, like this. So you can see that is pretty secure in there, and you're able to tighten and loosen the screw in this foot using this. And what's the big deal? You know, why is that such a big deal? I mean, can't you just use a wood screw? Well, one problem with using wood screws, we figured, was, let's say that wood screw has a Phillips head tip on it, and you have a Phillips head screwdriver like this, which this is just a tool and this is just resembling one, but you have to come straight down like this into the top of that screw to loosen or tighten that screw like this. And as you can see, you get really close to the sculpture itself, and you can actually ruin the sculpture while you're trying to screw in and out the screw holding down your puppet's feet. But with this, what you can do is you can just get down here real low and never be even close to your sculpture up here, and still loosen and tighten these screws. And it turns out, and I didn't realize that you could use machine screws in wood like this, but these here are actually flat-ended, and I'm assuming that what the person did who mounted this was they just drilled a hole through the wood to hold that puppet's feet down. So that's just a little tip if you're not wanting to ruin a sculpture and at the same time tie your puppet's feet down. And of course, when you're animating, you would want to drill holes in front of the puppet wherever you expect your puppet's feet to land first. And then in the case with like this California raisin here, the front part of the shoe was sculpted out of some type of material. I'm guessing a soft clay. And then every time an animator would want this foot to lift off, they would take the front of the shoe off and screw this into the foot, or unscrew this from the wood, put the shoe back on to cover where this was, and then lift the foot off. And when the foot would land, they would have this foot land on a hole which was pre-drilled. They would remove the soft sculpted foot. You know, let's say that's the front of the shoe and it's made out of soft clay. That would cover everything, and they would take that off, put that screw into the hole, screw it down, and then replace the front of the shoe, so you never even knew what happened. So just a tip that I thought was kind of cool. And the next thing we're going to talk about on our other puppet here is eyelids. And you can see on a California Raisin we've got a different colored eyelid over his eyes. And eyelids are extremely important because it helps a character to blink and to show expression. And as you can see, our character here is he looks like he's scared to death. And we're going to talk about how we go about adding eyelids to a character. And as you can see, we've got a white male, obviously, and we use the plain old flesh colored clay, Van Aken based clay, and we've taken a little piece of red clay and mixed it in with the flesh colored clay to get a sort of well, not really rosy, but a sort of pale pink color, which is darker than the color of the skin. And how we would manipulate the eyelids is you would just take a small piece of clay off of our new color that we've created, and just take it and make a small snake like this out of the clay. And we're going to make it about the thickness that we want. It doesn't matter how long. Let me zoom in a little bit. So we've got this really tiny thin snake of clay, and I'm going to take a tool I've got sort of a sharp knife tool here. I'm going to lay that on there. I'm going to stick it down a little bit if I can. And I'm going to cut it where I need there to be only an eyelid. And now I'm going to pop it off. Oops. And that's a common occurrence in animation, is the eyelids always fall off. So what I've got is I've got a piece of clay, and I know that's the right amount of clay for this eyelid, and I'm not actually going to use what I just made. I'm going to make it into a ball and then remake the snake. Let's see here. It's kind of hard to do here, but what I've got is I've got the right amount of clay, which I've reshaped again so that it's perfect on both ends. I don't have that sharp edge where I cut with the knife. And now I'm just going to take what I made and press it right onto our puppet's upper eye, like this. And make sure it's where I want it. And there's an eyelid. And you do this to both sides. Now we're going to make another snake. And maybe add some lids to the bottom of his eye. And using tools is something that you really have to rely on. Like right now I'm going to take this pin and stick it on this eyelid, then I can more easily place this on his eye, because you know your fingers are a lot bigger than the eyelid, and maybe I'll even use it to push it down on there. But that's how you stick eyelids on. And when you're animating an eyelid, what you want to do is you want to take and actually create replacements. Like for example, I'm going to take another piece of clay, there we are, and make a flattened out piece, and take a tool, and then I'm going to scribe a small line like this. And if we wanted a character to blink, we would first remove the original eye lids that we put on there, and I'll demonstrate on this eye here. You would remove that altogether, and then replace with something like a flat piece like this. It'll fit over the eyeball completely. And then you might want to take a tool and just kind of conform it to the eyeball as best as you can. Sometimes it takes more than one tool actually. Just kind of go like this. And then describe our little line. And he's got a closed eyeball. And I used, of course, the same pink clay which we created. And you might not want to close an eye completely like this during animation. You might want to have an in-between of the first lid, the second lid, and you might want to make something in between, whoops, what that was and that. It just depends on how many frames you want a blink to cover. And a fast blink would require only one lid like this for maybe two, you might want to hold this for 2 frames or so at 24 frames a second for that to look right. So that pretty much shows you how you would create a blink. And when you want a blink to return back to the normal shape, you just take a tool, pop that off of there, and you might want to save it for later. So I've got an eyelid for later, which I'll put on the side someplace in a clean spot. And then since I just plopped these other eyelids on the table below, we can just put them right back and reuse that. Oh, it doesn't want to stay on there. But so over a period of a shot, those are some of the things you run into, and but it's very simple, very basic. And the other thing is to physically animate the eyebrows, which are, like on this case, I have some large, bushy, white eyebrows. And to do that, now these eyebrows have been sitting on this puppet for a long time, so it might be kind of difficult for me to pop these off, but let's see. Oh, they come off pretty easily. But you want the eyebrows to sit physically on the puppet loosely. You never want to really push the clay down, because if you do, it just makes it really difficult to animate them. But for an eyebrow, to animate it, you would just maybe remove it and then reposition it however you like. So if he's starting to get kind of angry, maybe he's making more of a frown. Like this. So he's starting to get kind of suspicious now, Maybe he sees something over here that, he doesn't like or something, and, so you want to change his expression. And 90% of a character's expression is actually everything from here up. Things like frown lines. Let's say, for example, now his eyebrows have gone downwards, so we want to have maybe the skin above where his eyebrow is would actually smooth out like this. And that's something which, if you watch some of the older Vinton animation, you'll see that they actually will smooth and add wrinkle lines to characters above their eyebrows. And to smooth out these parts that we've got tool marks now, we just take some mineral oil, which looks like this, just a big bottle of it. And let me zoom out. I've got our mineral oil here, and I'm going to take my tool, I'm going to dip the tip into it, and just let's see, zoom in again. Right next to my puppet's feet, since my camera is not on that area, I'm just going to add a little drop of that mineral oil right there. And now I can dip my finger there into that and smooth out this guy's forehead, which I'll show you right now. Just take a little drop, take my finger, smooth out those wrinkle lines like this. Kind of like that. Now we've got a smooth forehead. Now, the opposite happens if we change his eyebrows like this. Oops. As you can see, parts will start to fall off, which happens really frequently. You always have to kind of worry about that, because your eyelids will end up on the floor someplace, like that, unfortunately. But let's make him look kind of scared, and his eyes are wide open, like this. Now, the eyelids, or the eyebrows by themselves, moving them up like this, looks kind of bad. You know, it doesn't look professional. You know, he looks kind of scared already, but with clay, what you're able to do is you can take, you physically resculpt his brow so the skin itself moves up. So I'm going to remove the eyebrows, resculpt this, and so his eyebrows would move up and everything above there would kind of get scrunched, if you can imagine that. And sometimes you'll put lines like that on there and you don't like it or whatever. You can always remove the lines. Take your finger and dip it in your mineral oil and smooth out whatever you don't like. Re-add lines wherever you want. And then once you think you've got it, and things are starting to look right, then we add our eyebrows again. Now we've got a new expression there. And of course that's not the most perfect thing. I'm kind of rushing here just for the fact that I'm making this film to demonstrate how it's done. But that kind of gives you an idea of what is involved in creating new expressions. And that's pretty much how it's done. And the next part is the mouth, which is extremely important. How do we make this guy talk? Now that is a more complex, it's sort of a complex thing, but we have to modify the mouth to animate it. When the mouth opens, obviously there needs to be teeth, there needs to be a tongue, and the top teeth, which are going to be under here, are mostly permanent and never move during animation, but the bottom teeth, they move with the jaw up and down, of course. So we had to modify the mouth to add some teeth, and I'm going to look at one of our raisin characters and see what I've actually learned here. Now one of the things that Wolf Vinton had done is they had figured out that if you take clay, and specifically Van Aken brand clay, and melt it down, and and add beeswax to the melted batch, you get a harder clay for teeth. And you want harder clay because when you're animating the lips, you don't want to end up dinging the teeth with your tools, which will show up. So one thing you might want to try doing is taking some beeswax, a small amount, and adding it to some white clay like this. And we're going to take our character and we're going to start to modify him. And if you have my How to Sculpt Puppets video, you're probably up to this stage on your own puppet. And what's involved is you want to take a sharp tool, kind of like this, and you want to cut along the mouth, a straight line right underneath there, right through, nice and deep, like this. And then down the side, on the side, and right underneath. You want to cut under his neck. And you want to physically take this mouth off. Hopefully carefully. You don't want to ruin your puppet, of course. And we're going to take his mouth. Let's see. Like this. And so now he looks scared and like he's been hacked up by some kind of murderer. And of course that's not what we want. But what we're going to do is we're going to take a loop tool like this, which you can find in most hobby shops, something like just a wire loop tool. And we're going to cut out the back of his mouth. And we're going to cut underneath his upper lip to hollow it out slightly. And the next step is to take some black clay and we're going to add it to the back of his mouth. So I don't have any, and I'm going to have to go upstairs for some, so one sec. Okay, so I got some black clay, and I'm going to take a small piece and make a little ball and flatten this out. So I got like a little pancake of clay. And I'm going to carefully take this and put that right in the back of his mouth, like that. And take a tool now and push it down like this. So the back of his mouth has some black clay. Now I'm going to clean the tips of my fingers by dip them in some water and wipe them off on a piece of paper towel. Now I'm going to take some white clay. And this has got some yellow mixed in with it, so it's more like the teeth color of people. Let's see. And another thing you can do is you can take some Super Sculpey hardening clay and put hardened teeth in there and paint it with some white enamel paints. And that'll also be the same as adding beeswax to Van Aken. It'll allow you to less likely to mess up. So when you're animating your character, and if you ding the teeth and they're really hard, you won't see any mess ups. So here we're just going to place this piece of white clay right where his teeth ought to be. And we're going to take a tool and just press it up in there. So now we got some upper teeth. And now here's his lower jaw, which we cut off. And we need to hollow this out. So I'm going to cut away where the inside of that would be. So his mouth will be completely hollow. And we're just going to scoop it away like this. very carefully. And we don't want to remove too much of the lips. We want those to be there so we can animate those. And look a little more. And then we're just going to smooth out the tool marks that we just made. And then I'm going to take and test fit this on there. See what that looks like. And you can see now it's starting to look like a real face. You know, we got some teeth in his mouth. And when you see inside his mouth, it's black. So it doesn't look, you know, like he's really, you know, a clay character anymore. He looks more realistic. So the last part is to add the lower teeth. So I'm just going to take another piece of white clay and take a smaller piece now. I'm going to remove his jaw. And I'm going to take this clay here. Got a piece of red in there, unfortunately. Let's see. Just kind of go like that. I'm going to take my pen. And I'm going to place that where his lower teeth would meet his upper teeth. And press them on, just lightly. And now I'm going to add his lower jaw, like this. And then we're going to take a tool and we're going to smooth where the two parts meet, where we made that first cut, like this. And one of the problems with this method is the character, when you animate him a lot, will start to change shape and it won't end up looking like your character anymore. So you always gotta sort of be conscious of what your character looked like before you really get into physically animating too much. And so it's really important maybe to, you know, if you have a digital camera, you might want to take a picture of your character before you animate them. And that way you can refer maybe to it later on. Let's say 100 frames later, you know, when you're animating and you're thinking that your character starts to look like another person, you can refer to your digital still picture and get your character to look, you know, the way he should or she should. So that's how you modify the mouth. And when you have a character talk, you can open and close the mouth like this for animation. And anytime you move the mouth and you want, you know, what will happen is you can see in the sides. Let's see if I can zoom in on this guy here. See, the sides of his mouth will start to fall off because there's not as much clay there. So you just always gotta take your tool and smooth it out and, you know, make it look like his mouth is physically flexing instead of breaking as it's being animated. And sometimes you have to take small pieces of clay and stick them on like this. And then blend this in. And that's kind of, you know, for a character like this, you can animate, you know, pretty well by doing just that, just by bending the mouth and whatnot. But for different mouth shapes, usually what you do, like let's say for example he says the word what, and he makes the W sound or the ooh sound with his mouth. What you usually do with the old-fashioned method for resculpting the face is you would take a piece of clay and you would, let's say, stick it on like this onto his mouth and resculpt the entire mouth like this. And then you have to take your tools and whatnot. And let's see. The one tool that I need I have upstairs, but let's see if I can do it with this tool. And you would resculpt the ooh shape like this. And you can see, you know, clay animation, just by watching, you can see it's a labor-intensive kind of process. You know, using this particular old method where you have to be skilled as a sculptor to, you know, reshape a character's mouth often over a long period of time. Because clay animation is a slow process. But this gives you an idea of what's involved in reshaping a mouth for animation. And there you have it, something like this. That's what this guy would look like if you made the ooh shape. And the right tools will help a lot. So if you like to sculpt, you might want to just start collecting as many as you can, and then you always end up using tools more often than you might suspect, like this little ball tool. And now another trick I wanted to show was, now I've sculpted this guy's mouth in the ooh shape, and I've added clay to this. Now if I want him to say the ooh shape later on during a shot, what I would do is I would actually cut what I just put on off like this. And this looks pretty horrible, but later on what I can do is I can plot that back onto his face later, and that will save me time resculpting this guy's face. So like right now, you know, once you take that off, what you had to do is physically resculpt the mess you've made, basically. And you know, so that's why good sculpting skills and clay animation go hand in hand, because I mean, you can see it's going to take me a while to resculpt this. But the next thing I want to show is how to use replacement mouths for a character, which is a process which makes the, you know, animating a character go a lot faster than what you see here. And replacement faces, I've actually figured out a way to do it and to save a lot of time, and to also sort of, now like the way I'm doing, actually animating this guy's face here is the old-fashioned way, and the new way is to just make a small mouth and to make like this whole area smooth with no lips, no nothing, just a flat area. And to me, I think like if you watch MTV's Celebrity Deathmatch, it just looks really crappy. You know, they have these little mouths that they stick on there like this, and you know, there's a mouth shape, you know, and it just looks really bad to me. But one way to take a face like this and to make replacements is to first sculpt the face until it's in a very finished form, and then to cut off the area like this from here to here, across, and then down the sides on a face. So you got a line across and then down. Then we're going to pop that off and make a mold of this area, and then make multiple parts of this. Okay, replacement mouths are a way to allow your puppet to speak using very fast animation techniques. Uh, for example, you see here are several mouths in different mouth positions. And how this works is this is Evil Toad, the green guy here, and you can see where the clay on glass technique is where you lay all these on a sheet of glass and you line things up. For example, here's his body, and we have his mouth, and we can give him, arms and hands and make a complete character this way. So Evil Toad is kind of a fun character. I've created a ton of different mouth shapes, like this one, which we would remove a mouth and place a new one where the first one was, for him to actually maneuver his mouth for different words. The process of making replacement mouths like this involves making a sculpture like this, and this is an original sculpture I used, and I made a mold of this, and what that requires is taking your original sculpture and laying it flat on a table and adding clay around it like this. And you want to make it a little bit higher than what I have here, but that's how you make a basic wall of clay around a sculpture. Then you want to take this stuff here, which is AccuCast Dental Alginate from Berman Industries, and Berman Industries is www.bermanfoam.com, or you can call 818-782-9833. And what alginate actually is just a powder like flour, and you mix this with about maybe 50-50 with water, and it turns into a mostly, I guess, kind of like pancake batter in a way. It's sort of a thick bunch of stuff. It's very slimy, and you simply would pour a cupful or so over your character's face, your sculpture, and then once that hardens, you would pull that out, take the walls down, turn it upside down, and take your face out of the mold. And the mold will be very soft and very watery. And then you simply take a double boiler, and now this trick only works with Van Aken based clays. Now, New Plast clay or English clay doesn't melt, so you can't do this trick, but with Van Aken, luckily you can. And Van Aken brand clay, you can go to vanaken.com for if you need to find locations near you where it is. But you'll take a double boiler, and what that is you take a pan or a pot and fill it with water, and then place another pot over that with your clay so that your clay doesn't burn. Once you do that, you melt it down and you pour, like in this case I've got this lime green color which I made up, and I poured that into the mold, which is obviously, once you make the mold, it's a negative of your original sculpture, so it looks kind of like this but hollowed out. And you pour your clay into the mold until it fills up. So, like, pretend my fingers here are the mold, and we had this flat on the ground, we would pour the clay in until it reaches the height of the top of the mold like that, and then you would pull out the clay out of the mold carefully, and you would get a duplicate of your original sculpture. And then what you want to do is you want to make a ton of duplicates like you see here. These are all duplicates, and the reason they have this little dot is because there is an air bubble in the mold, so that actually casts air bubbles. But the purpose of this is you have the same volume of clay for each mouth, and you can reshape those mouths into these kinds of shapes. So we got teeth added and tongues, and you got the U shape, the L shape, and whatnot. And what I had mentioned before about our first puppet here is we sculpt the mouth, and then we cut it off like this. And then what we have, here's the side and the front of his mouth, and the bottom, and that's the top. You can see it just fits back on there like this. Now to make a mold of this, we would just lay it on a table, add your clay around it like this, make a dam, make sure it's nice and tight, and that when you pour your pancake batter like dental alginate in there, that it won't seep out any of these edges. And it takes about maybe 15 minutes to set up. Then you would pull your alginate out of here, turn it upside down, and then pull out your original mouth and make duplicates of this, just like these. And then all you would do is you would have a bunch of these, same exact size, shape, and everything as this. And then you would reshape this mouth, exactly like you see these, into the different mouth positions for speech. And then once you have all these different mouth positions, when you animate your character, it's just a matter of removing one and plopping the next one back on. And every time you would add a new mouth shape on for animation, you would have to just smooth out that line, that seam, and then you would have a new mouth position. So it's pretty simple to do that. And that's just a trick that I came up with, which it sort of is a modern way to do the old way, which I showed you before, where you physically reshape the mouth for every mouth position, which is a really long, tedious task. By doing it this way with the removable mouth, it's a lot simpler to just smooth out a seam after replacing the mouth like this. It's easier just to smooth out that seam than to resculpt the entire face over and over again. And another reason why it's good to do it this way is because your character won't look like some other character 50 frames into your shot. So that's just a way I came up with, which I think is the best way to make the character look intricate and complex like this, as well as to save time by using replacement mouths, because it's just a matter of replacing one shape like this, and adding another one, and that's it. And the next thing that you want to keep in mind with animation is with our exposure sheets. Once we have marked on here the letters which correspond with what the character says, and we have it all broken down, let's say our character says the word cat, and it starts on frame 16, it looks something like this. So the word C is held for 3 frames, A for that number of frames, and T for that number of frames. And you always want to have something, either a tape recorder or a CD player, which is portable. nowadays you can actually put WAV files on a CD to listen to them. And you want to always listen to your voice track while you're animating your character from one pose to the next, because you want to have any sort of changes in the voice that your voice actor has created into a WAV file, and accent the sounds of the voice into what the character does. So if a character says, wow, he's really excited, and the O is the loudest part, so wow, he would go, wow, like this. And you want to have your pose, let's say his arms come out like that, and you want the arms to come out like this, and you want them to be extended at the farthest points, like they are now, pretty much. And you want this pose to be hit when he says the O, which is the most accented part of the word that, if a character goes, wow. So the O is the most expressive part of the word, and he would hit his pose on the frame where the word O is. So like we had written down the word cat. So if he goes cat like that, you'd hit that pose in the middle of the A sound, in the middle of the A in the word cat. And that's pretty much how you work the actual recorded sounds into the poses. So that's important. Another thing is when you're animating, you want really dark colored clothing. You don't want to wear white clothes, because when you have lights around a character like this, if I were to wear a white shirt, I might actually reflect. Let's see if I can. Well, the way the lights are here, you can't really tell, but maybe you can tell like this. I'll put this paper in front of him. I don't know if you can see that, but depending on where this white piece of paper is, the light is shifting on the puppet from lighter to darker. And in a lot of situations, if you're wearing a white t-shirt or like a neon green t-shirt, you'll actually get a flicker in your animation, because when you move around a room and you click off frames of film or digital still images, if light is bouncing off of you and onto your character in different spots, you'll mess up your animation. So you want to make sure you're wearing dark clothing. You can see the back of our character here is not completed. And we decided that for this particular shot, we don't actually need to see the back of his body. So nothing is sculpted. And it does two things. Since there's no clay back here, that will make this puppet lighter. And the lighter a puppet is, the better, because you don't want the puppet to sag or fall over. Okay, the next thing we're going to cover is how to make a character walk. Here you can see we got this puppet which has 2 aluminum feet which have the capability of tie downs being put under the set through holes to tie the feet down. To make a character walk, the steps that you want to follow to do it are, first you want to take something and draw a line of the path that you want the character to take. If you have a really nice set and you don't want to mark it up, you want to use something like a piece of tape and just draw a line, or put your tape down. And the next thing you want to do is figure out the stride that your character is going to take. And what that is the distance between one step and the next. So we've positioned this puppet where he's taking a step, and what we do is we mark dots. We can take pieces of clay, and if your camera is not going to see this, you can just draw lines. But you can take pieces of clay and put them down where the character's feet will land. And that's one step. And there's maybe another step. Oops. And we would mark each step according to the stride. And once you get the feel of it, you can judge the distance by just looking at the table. So you would draw little dots where the foot lands and where the hole of your tapped hole on your feet lands, or if you're using an aluminum wire puppet, you would just figure out where those loops land, and once you know and you mark, what you would then do is you would drill, taking a drill bit, and drill holes through each one of those marks. So you'd have a series of small holes in your set, and the next step is to fill each of those holes with little pieces of clay to match the color of your set floor. And you only do that if you're going to actually see the floor in your animation. So it depends on the shot, really. If you're not going to see the floor, you can just leave the holes as they are. Or if you have pegboard, there's no need to drill holes because the pegboard set floor already has the holes there. You just have to make sure to take like little pieces of tape and paint them to match the paper that you have covering the pegboard floor. And once you have the holes in the floor, if you're using aluminum wire looped feet, you can take, like I showed before with those California raisins, one of these hexagonal screws and an Allen wrench, and literally right through the hole in your puppet's loop of a foot, just tie them down for each step. And the way you time a step, you of course use the exposure sheets. So if you think that a puppet is walking kind of fast, 1, 2, 3, 4, 5, 6, steps like that, you would just time it out with the stopwatch and figure out how many frames that puppet is going to take up between steps. So it'd be like, 1, 2, 3, 4, like that. And when you move a foot down and it lands, of course you would take a tie down underneath the table and tie this foot down while removing the tie down from the opposite foot so that it can move. What a walk looks like. Let's see here. And here you can see from an animation book that I've got a basic walk. Now the toe, and they actually show where the toe and the heel hit the ground, but a lot of times your puppets won't have toes, so you usually keep the feet flat in most cases, at least with clay characters because they're pretty heavy. But as a general rule, how it works is the body will lean forward, and what it's doing is it's actually catching itself as it falls. So the body is always in a falling motion, and the legs move in front to catch the fall, and then the next leg moves forward, and the cycle is repeated using the opposite leg. And some other pointers would be the body leans most forward when the legs are farthest apart, and the body almost comes up straight when the two legs are side by side. And one of the legs that's tied down to your set is almost straight up and down when the two legs are side by side, and it bends most when one foot finally lands. So that's a basic walk cycle and what it looks like from the side. And one tip for animating a walk is that your left leg and your right arm generally will be in a rear position, while your left arm and right leg will be in a forward position during a walk. Pretty much the right arm follows, or the left arm follows what the right leg does, and the right arm follows what the left leg does. So when the left leg moves forward, the right leg moves forward. When the right leg moves backwards, the left arm moves backwards. And when you're walking a character, you want to make sure that they're constantly leaning forward slightly like this. When the legs are together, like I said, when the legs are together in an animation cycle, the body's almost straight up and down. And when the legs are furthest apart, like this, the character is leaning the furthest forward, like that. So that's how it appears from the side. When a character is also walking and you see them from the front, as you can see, this back leg is touching the ground. And the way the body actually physically compensates for that problem is it raises the hip so that that leg is off the ground and can freely move forward. So when a character's hip moves up for that leg to move forward like that, the body itself will bend in the direction opposite, so that the shoulders, like the left hip and the left shoulder, will move towards each other when the left leg is off the ground. And the same is true that when the left leg is on the ground, the right hip moves up and the right shoulder will move down. So it's kind of hard to explain, really, because it's such a complex thing, but that's how the body balances itself. When the body moves forward like this, you see how it kind of hunches over slightly? Well, you see how that leg here will move up right here. So this tends to move up along with the body. And as a rule, you don't want the ankle to go backwards during a walk. The feet are always in a constant forward motion. There's nothing like this. You know, that's a common mistake. So the ankles, make sure they're always moving forward during a walk. And I've got some detachable parts, like this hand will actually unplug using one of these brass sockets. And that just is a matter of taking some brass tubing, which is in different sizes, and cutting it so that one will fit into the other and be able to plug in and unplug from the body. And you can actually do that with whole entire body sections. Like I can have this guy's upper body detached from his waist if I wanted to, if I design it that way. So a lot of times with really short, stubby characters, you almost always have to make replacement legs, which usually, you take something like really stiff steel wire and position, just as we showed before. You might have that many number of different replacement lower legs out of steel wire. And when a character walks, you have to pop the body off for each movement and pop it back onto a different pair of legs. Let's see, we've got some letters here. People wanting to know how to do things. And Nathan says, I'm trying to get a hold of, get my puppets to hold something in their hands, like a tennis racket, but it seems way too heavy for the hands to hold. So I guess that's a a problem which might be encountered. And we'll take this guy as an example, and we're going to take a pen and have him grab it. And you can see that this guy's arm isn't really going anywhere. And the reason for that is because this pen is really light. And so if you have a problem with the character's arm falling when they hold something, it's really a matter of just taking that character's prop that he's holding and making sure that it's really lightweight. When you make a prop for a character, use something like foam or just lightweight materials like balsa wood. And if it's supposed to look like metal, just paint it with acrylic paints, metallic acrylic paints. And I think that will cover pretty much, all the problems encountered with heavy items. Standing on their hands, how do you get a puppet to stand on their hands? Well, what you would do is essentially is, just like a puppet who has tie downs for feet, or you can put a threaded rod into there, you would just do the same thing with the arms or the hands. So if a character is going to be doing, tumble salts or whatever, you would just have to make sure that the arms are solid enough and strong enough to hold the weight of the entire body and place tie downs in the hands, just like you would. You don't always need to have all the body parts moving all the time. It's like a common mistake with clay puppets in animation is when you're animating and you have a lot going on. If a character is always constantly moving, it makes you feel kind of uneasy, and it's not very realistic. So if we're having him talk and his arm is, maybe he's got one hand in this position for most of the time while the other hand makes the gesturing while he talks. So he says something like, well, today I just went out to the park and I saw this dog and blah blah blah, blah blah blah. And when he puts his hands together, there's a pause. So you hold that position while he talks, and he holds it for as long as he wants. And maybe now he's, if he was listening to someone talk to the side and the camera was still on him, he would hold this position until he started to talk again. So, he's listening to, his secretary in the office, and she's like, well, somebody put in 10 cups of sugar in my coffee this morning, and he just kind of stands there and maybe nods, and he says, well, you really should watch your coffee more carefully, and whatever, So his arm, we have this arm which is always being in this position for the most part, and we have one hand that would come out often to accent what he's saying, and then, when he's done talking, he wouldn't do much at all. He would just kind of stand there like this. So holding is always an important part of animation, and there's actually no animation involved. There's no movement, except maybe a blink or two, just so he's alive. So holds are use anticipation in a lot of things. Like let's say this guy's going to move his arms up. Anticipation is first he moves them down and then up. So it's almost like an implosion and an explosion of however he moves. What would be another example? I guess, any sort of surprise motion. Somebody does something horrible, and at first he sees it, doesn't think much, and then it registers in his head and he looks quick. Or any movement outward is first, you first move the body parts in the opposite motion and then up. And if you're using anticipation while he's talking, before you accent a word with an outward motion, you have to make sure that your anticipation comes before the word itself. So like we said before, the word cat, where he says, you know, let's say he's going to say, I saw a cat. So the word cat is going to be accented by an outward motion on the A sound. He just lost his bads there. But, so he would say, I saw a cat. So, I saw a cat. Anticipation is actually in the first three words, which is I saw a, and then cat, like this. So that's anticipation. It's a move before the main move of any motion your character makes. Now that we've been moving our puppet around, you can see we're having some problems. What we've got cracking and crumbling in the jointed areas, like here and in this area. And that's a really common thing, and it's something which I'm going to cover next because it's so common that people ask me all the time how it is that you fix a character from crumbling and cracking. And actually, you can't fix it. I mean, you can't do a whole lot about it. It's just something which happens no matter what. I mean, it's going to happen, and the only way to fix that is to repair those problems by resculpting the area or just patching it while you're physically animating the puppet. You know, in between a move, if you see that crack starting to happen, you just take a tool and just go over all these areas. Another thing you can try is to take a double boiler and melt your Van Aken based clays down in a double boiler and add about a teaspoon of mineral oil to your clay. And what that'll do is it will soften up the clay slightly, and it will allow the clay to be more flexible and less likely to crack. But as you can see, this is all it really takes to patch up those problems. So it's really no big deal. You know, a lot of people think it's, you know, the end of the world. But the only way, you know, the only kinds of puppets that don't have this problem are made out of like silicone or foam latex. So during animation, you just want to patch it up, just like that. Any place that there's a crack or anything in a joint. And to demonstrate how to clean off dirt on the puppet, you've got some dirt on this guy's forehead. Right here, as you can see, it's actually some black clay. And I mentioned before, you just take a sharp object and scrape that clay off. And that's what we're going to do. We're just going to take one of our sculpting tools here, and just get in there and remove those darkened, dirty areas, and then smooth out what we just did, like this. So we just fixed those problems. Then you can take mineral oil on your finger and just, you know, smooth it out perfectly. I'm just going to quickly cover how to animate water. And water in clay animation, one of the tricks is to take clear plastic wrap, and if you have something like a spout of water, let's say we have something like a sewer pipe which breaks and water starts to come out of it. One of the tricks is to take plastic wrap like this, and anytime you have running water, you can kind of see how that looks. Such a big piece, but just take a small piece of plastic wrap and just crinkle it a little bit in your fingers and place it on your set, and that will look like a water splash. So if you have a scene where there's a lot of rain, you would just have it splash like that. Now if you have a glass window and you want to animate water going down a glass window, like let's say for example our bottle of mineral oil here, there is stuff called glycerin which is kind of like mineral oil, and it's sort of more of a solid material. Let's see. Now I just placed a drop of mineral oil right there. You'll notice that I can't really animate this. If it was too thick or there was too much oil, it would just drip by itself. What glycerin is, and it's used to decorate cakes. So like if you go to a cake shop, you can find it, and it's clear, but it's also kind of thick. So you're able to take that glycerin and just take a tool and move it around like this. And for each scene, if you have water sliding down a window, you would just move it down further and further and further. Kind of works with mineral oil too, as you can see right there, but it's not as effective as glycerin. And of course, you can mix glycerin with food coloring, like red food coloring, for blood, or whatever. Let's say you have some sort of green toxic ooze. You would just take some green food coloring and mix it in with the glycerin, and if you have a window or something, you can just physically animate that. So that kind of covers the water side of things. And liquids. If you have liquids which are, let's say someone spills a cup of something, maybe they're drinking a glass of milk or something, you can take plastic, acrylic sheeting, which, what do you call it, plexiglass, that's it, plexiglass, and just cut out shapes. And you would start from a small shape to a large shape. Maybe this would be your first little piece, and the second piece would be slightly bigger, and then the third piece would be something like this. And then when you're animating it, you would put this piece in first, then this piece, and this piece, and get as large as you wanted. That's one of the old tricks. And to color that, you would have to take translucent paints, which they sell for model racing cars, like the kind that are motorized. They actually sell translucent paints which you can shine a light through. I think Tamiya paints. Those are one brand that you can buy. Now for fire, the same thing kind of applies, except you would take something like a light gel like this. And light gels you can get from HollywoodLights.com. I believe they sell these. And you can get them in different colors like red, blue, green. And you would make replacement shapes of fire like this. Except you would cut those shapes into your clear plastic. And then you can shine a light underneath your set in a hole up through this gel, so it appears to be emanating a light, just like a fire. Okay, I'm going to briefly talk about how to make things hover. Here you can see you've got this ball here, and chances are you probably can't tell very easily what's holding this up off the ground. There's no wires or anything. The trick is actually to go ahead and take your puppet, and this is just an example, it's just a ball of clay, but you take your puppet and you design it so that you can insert a rod into the back of it, which will stick into the back of your set. So when we come over to the side here, you can see it's just a stick that's poked through the back of our clay and supported, just by some everyday objects. So this, of course, isn't very secure, and you can't animate it really very well either. But just to show you an example of building an armature that is able to accept something like a rod, which will support the entire body. You can see this armature was designed so that you can insert a piece of brass tubing and tie it down using a set screw. And that's a really complex way to do it. But making a puppet fly really you have to build two things. You need to build a rig, and you need to build the armature which will support the rig that you built. And we've got an original rig. So we got this rig which would stick into the back of a puppet, and it would stick into the back of a puppet which was designed for this rig. So like for example, we have our puppet which will allow a piece of brass tubing to stick into it like that and into the back of a set. Now you would have to have a slot in the set for this to move up and down, but they also have they built a rig to move up and down like this. So if you can imagine having a set wall, this would stick through the wall behind it and would be able to move up and down. Doesn't want to move. Here we go. So it would be like this, with the rod sticking through the set wall and then into the back of a puppet. The whole idea is that you're able to support a character like this. So we have the set wall, we have the rod that comes through it, which is attached to a rig that will move up and down. So if a puppet, let's say, jumps and you want it to move up and down, and then the camera angle is also like this, so you can never see that rod. There might be a hole in the wall, but you would have to design that wall for that specific shot. The other thing is you want to make sure that your lights don't cast shadows on the rod that will give away the trick. Okay, the last part of the tutorial, I'm just going to talk about how you break down the sound for your animation. And as you can see here, we've got a program, and what all this is we have a wave file, which I had a friend record his voice for our FBI character. I'm the FBI. And you can see the wave up top here. It's a wave file, and you can also see frame numbers 0 through 56. And this here will actually break down the sound. You can play certain parts of the wave. So you can kind of see. So whatever we highlight on our waveform here will be highlighted in a frame number, and we can actually play just that section. And if you listen, that's definitely an I sound. So what we'll do is we'll come over to the left here, look up the I, double click it, and we know that for frames 0 through 5 we had to make the I-shaped mouth face for our character for those first 5 frames. And this is based on 24 frames per second. And you keep doing the same thing. So it's like I and an E there. I. So you keep looking up, or you break down each section. We know that's an I again, so the I is going to be held for 8 frames. So I highlight the next few frames, and that's the E sound. So we're going to select the E, double click it, and we know that frames 9, 10, 11, and 12 are the E-shaped mouth face for our character. It is Stop Motion Pro, and I brought this program a while back, and it's a great program. You can animate your characters using it, and it's just a really easy program, and it's something I highly recommend. If you want to do computer animation, Stop Motion Pro is one of the best. I mean, it really is. And we have a free program on our site called Anasazi, and it's just a very basic program. But this, you can import digital, really high quality digital still images and play them back. So highly recommended, and you can get this at stopmotionpro.com. As you can see, it works really well. I mean, I animated this a while back using my my digital camera, and you can shuffle between frames. You can view a live image of what you've got. You can view the stored images. You can edit individual frames. You can see here we've got all the frames that make up this particular animation are stored, and it'll break it down for you, so you can, maybe you want to delete that frame or copy it and then paste it again. Just really a flexible program. So highly recommended. Stop Motion Pro, and this is the light version, as you can see, and it's a great program, and it works really good when you use it along with Magpie, because if you can actually run both programs at the same time, and instead of having to print out the mouth positions, you can just look at your computer screen. So those two programs alone will cost you, $150 or so. I forget the actual price of Stop Motion Pro, but it's not too cheap. But they're great programs if you have a computer. So that concludes the tutorial on how to animate puppets. If you have any questions, you can visit us on the internet at animateclay.com.